Hello everyone, this is Safa Suleiman Sheikh and I welcome you back to your very own favorite channel Catalyst, where we turn your potential into power. Now, today's video is not a regular lecture. This is a full chemistry reactions marathon for class 10. Let's be honest, chemical reactions are one of the most confusing parts of class 10th chemistry. There are so many equations to remember, reactants get mixed up, products get forgotten, and in the exam, one small mistake can cause so many easy marks. So, in this video, we are going to be fixing that once and for all. In this marathon, we'll cover all the important chemical reactions from the class 10, the NCERT textbook syllabus, chapter by chapter, equation by equation in a very exam-oriented way. For every reaction, we'll be discussing what is the logic behind it, what is the experiment behind it, how to write the equation, how to balance it correctly, what kind of questions may come in the exam. You have a lot of competency-based questions, you have a lot of puzzle-type questions, which generally students find difficult. If you are asked a very straight-away question from the NCERT, you are able to solve it. But the minute it's slightly twisted, you're confused as to what reaction to write. If this is the problem you're facing, then this video is for you, because we will be discussing what kind of questions can be asked in the exam regarding that particular topic, that particular equation. And most importantly, we are going to learn how to remember the reactions easily without mugging them up. Yes, I agree, the video might be a little long, but trust me, by the end of this session, chemical reactions will stop being scary and start feeling amazing to you. So grab your notebooks, keep a pen ready, and do not skip this video, because this is not just revision, this is exam focused high written revision. Alright then, okay, let's stop memorizing blindly and start understanding reactions the smart way, the way you should be studying chemistry. Okay, before we jump into the video, I need to tell you a very important point. Remember, one thing for this marathon video is necessary. A lot of you may think, ma'am, it's 2 hours long, it's 3 hours long, it's such a long video, I'm just gonna play it at 2x and finish it off quickly, right? That's what a lot of you might have clicked onto the video thinking about. No, please do not do that. If simply listening was enough, you would already have been confident with chemical reactions. But the fact that you're still watching this video at this particular time means that you are still underconfident. And that's completely okay. It's completely fine. But remember, chemical reactions are not learned by listening. They are learned by writing. So what I want you to do is take a pen, a notebook, pause the video whenever required, understand one reaction and then write it yourself. Listen to me, understand it, pause the video, try to write the reaction on your own without seeing the video. If you're able to write it, well and good. If you're not able to write it, if some reaction feels difficult, write it 3 times, 4 times, 5 times, 10 times. It's okay. There's no shortcut over here. Okay? Writing is not a problem. Writing is the solution to solve the issue of not remembering the reactions. Just watching me explain is not going to help. Your hand needs to move, not just your eyes. Just by moving your eyes, just by listening, glancing at the video, it's not going to work at all. Your hands need to write. I may not be watching you, your parents might not be watching you, but be honest with yourself, because trust me, this honesty will pay you back in the exam. If you do this sincerely, I assure you, by the end of this video, your confidence in chemistry, especially the chemical reactions, will be completely different with what you have started now. Okay, so now I hope that you all are ready with your books, your pencils, and with your mind, your concentration completely over here. Fine. Now, before we begin with chemistry, what we will be doing is I will just give you a small basic intro of chemistry, as in the basics of chemistry. We'll just discuss it. That is how to write the compounds, chemical compounds, given it is an ionic compound. What are the cations? What are the anions? What are the charges? Okay. If somebody is thorough with this, if somebody knows how to write the chemical formulae of compounds very well, then you can skip this part. Please feel free to skip this part because this is something what you have learned in your lower classes. So you can skip it. It's nothing related to your 10th chemistry or your syllabus. Okay, this is for especially for those students who are finding it difficult to write the basic chemical formulae itself, and that is the biggest issue that they are facing in chemistry. The reason why they're not being able to remember the reactions is because they don't know this. Okay, so the first and foremost, remember how to write chemical formulae of compound and some basic chemistry related compounds. The chemicals, you need to remember them. Okay, so I'll just give you a light quick brush up of these concepts. We have the cations and the anions. Okay, what are the cations? Cations are the ones which are positively charged and anions are the ones which are negatively charged. Fine, as simple as that. Now, which are the cations that you should be remembering? Remember, there are cations which carry the charge +1 in them. Cations which carry the charge +1. Which are the cations that you should be remembering which have the +1 charge on them? Starting with hydrogen, H+, sodium, Na+, potassium, K+, lithium, Li+, and ammonium, NH4+. So these have single element in them. Okay, they have only one element with them, only hydrogen, only sodium, only potassium, only lithium. Whereas this is a polyatomic ion because it has one nitrogen atom in it and 4 hydrogen atoms within it. Okay, why am I specifying this over here that this has 1 nitrogen, 4 hydrogen? Because a lot of students don't understand this while balancing the chemical equations. Okay, so remember, this is a polyatomic ion which has 1 nitrogen atom in it and 4 hydrogen atoms within it. Fine. So these are the 5 cations that carry the charge +1. Hydrogen, sodium, potassium, lithium, ammonium. Now remember, there is a difference between ammonia gas and ammonium cation. This is the ammonium cation. Fine, I'm writing it here so that you remember the difference. Ammonium. Okay, when I say ammonia, okay, you can put it as a note over there. Whenever I say ammonia, it means NH3 gas. NH3 gas. But when I say ammonium, it means the cation NH4+. Fine. So these are the 5 major cations carrying the +1 charge that you should be remembering. Next, what about the +2 charge cations that you should be remembering? The list goes like this. Number 1, barium, Ba2+, calcium, Ca2+, copper 2, or which we call it as cupric ion. Okay, this is known as copper 2 or cupric ion. This is Cu2+. Okay, next we have magnesium, Mg2+, zinc 2+, Fe2+. Remember, Fe2+ is known as iron 2 cation or the ferrous cation. Okay, ferrous cation. Zinc, Fe2+. Okay, and then we have lead, Pb2+. So 1, 2, 3, 4, 5, 6, 7. 7 + 2 cations that you should be remembering. Okay, in the +1 ion, let me add one more over there, which is there in your syllabus, which is nothing but Ag+ for silver. Ag+ for silver. Fine. Now +2, barium, calcium, cupric, magnesium, zinc, ferrous, lead. These are the ones you should be remembering. Okay, and apart from this, plus 3 charged ion that you should be remembering is this one. Plus 3 charged one is Al3 plus aluminium and Fe3 plus, which is nothing but ferric. The difference between ferrous and ferric should be clear to you. Whenever we say ferrous, it is Fe2 plus. Whenever we say ferric, it is Fe3 plus. So here under the charge 3, we have only 2 ions majorly which you should be remembering. Aluminium 3 plus and ferric 3 plus. This is also known as iron 3 cation. Done? Okay. Now let us come to the anions list. Which are the anions that we should be remembering? Okay. The anions that you should be remembering are this. Mainly halogen family. Halogen family includes chlorine, bromine, iodine, fluorine. These are one family. Okay. These are the elements which are a family. They are like sisters or brothers, whatever you want. Okay, they generally show the similar type of properties and we call them as the halogen family. Which are these? Chlorine, bromine, iodine, fluorine. Okay, but remember when we name the ions, we name them as chloride ion, bromide ion, iodide ion and the fluoride ion, IDE. This word is used. Why am I telling you this? Because if I say chlorine, just like I told here, ammonium means NH4 plus and ammonia means NH3. Similarly, remember when I say chlorine, bromine, iodine, fluorine, then that means these are the gases we are telling about. We are talking about the gases over here, Cl2, Br2, I2, F2. Whenever in a chemical reaction it is told that there is chlorine being released, it does not mean Cl minus. It means it is the Cl2 gas which is being released. Okay. So IDE represents the ion and INE or the normal name what you refer, this refers to the gaseous state. I hope that is clear now. Fine. Chloride, bromide, fluoride, iodide, all of them have the charge -1 on them, -1. Okay. Apart from this, few more are there. Let us write those also. Which is there? We have the hydride ion, H minus, rarely used, okay, in your syllabus, but it's good to remember it. H minus ion, which is the hydride ion. If it is H plus, we call it hydrogen ion, and if it is H minus, we call it as the hydride ion. Got it? Next we have the OH minus ion, very important. This is the hydroxide ion, OH minus. Fine, OH minus, hydroxide ion. Next we have NO3 minus, this is the nitrate ion. Nitrate ion. Got it? Now here again, chlorine, bromine, iodine, fluorine, hydride. All of them are single elements. In OH you have 2 atoms, 1 oxygen, 1 hydrogen. In nitrate total you have 4 atoms, 1 nitrogen, 3 oxygen. This is what you should be knowing. So this is what we have in the -1 category. Okay. Next in the -2 category, what do we have? Some important ions again. O2 minus oxide, S2 minus sulfide, SO4 2 minus sulfate, SO4 3 minus sulfite, CO3 2 minus carbonate, and bicarbonate I remember that you have to add one more over here, HCO3 minus hydrogen carbonate. Okay, or this is also known as bicarbonate. Just add one more ion to your -1 list. Okay, HCO3 minus, which is called as the hydrogen carbonate ion or bicarbonate ion. In that we have one hydrogen atom, one carbon atom and 3 oxygen atoms. So this is also a polyatomic ion. Coming back to the -2 list, what do we have? Oxide, sulfide, sulfate. This is sulfite and this is carbonate. Very, very important. Sulfate, carbonate, regularly used in your syllabus. Got it? I hope this is clear now. The -2 ions that you have to remember. Again, remember when I say oxygen, if I say oxygen, then I will write O2. And when I say oxide, we will write O2 minus. Fine? Next, apart from this, which are the -3 ions that you should be remembering? The -3 charged ions you have to remember is one only, phosphate one. Okay, phosphate, PO4 3 minus. One phosphor, 4 oxygens are present in this particular ion. Okay, and the charge is 3 minus. Now one more thing, let me clarify over here. Remember here the charge is the one. If I ask what is the charge, then the charge is the one that you write on the top, not the one which you are writing at the bottom. So for example, if you take carbonate, what is the charge of carbonate? If this is asked, you will tell -2. You're not going to tell 3. This 3 just indicates that there are 3 oxygen atoms present in the ion. Okay, but what is the charge? The charge is -2. That is why I have separately written the charge over here so that you can remember them as a list of ions which come under -2 charge. The charge over here is -2. Okay, now students, so this is the list of cations, this is the list of anions. For those who already know this and those who understand this very well, well and good. As I told, you can skip this part of the video also, and if you want to just brush up the topic, then please feel free to watch it. Okay, but for the students who are feeling of what is this feels like something new, or you feel that you're not thorough with this concept, then please pause the video, write down all the cations, write down all the anions, learn them properly, write them once, twice, thrice at least without saying, and only then proceed forward with the video. So I am hoping that you have paused the video and you have learnt it and you have come back. Okay, so let us now continue as to how to write the chemical formulae. Before that, before I come to how to write the chemical formulae, let me just put up some important other compounds over here too. Okay, now these are your cations, anions. Apart from this, what are the common chemical compounds you should be remembering? Common chemical compounds that you should be remembering are these. If I say oxygen gas, then it is O2. If I say chlorine gas, it is Cl2. If I don't say the word gas also, if I just say oxygen, you should automatically write O2. If I say chlorine, you will write Cl2. If I say hydrogen, then you are going to write H2. If I say carbon dioxide, you are going to write CO2. If I say carbon monoxide, you are going to write CO. Mono means one. Got it? So these are some of the commonly used chemical compounds which you should be knowing. Oxygen, chlorine, hydrogen, carbon dioxide, carbon monoxide. Anywhere in the reaction I tell you that oxygen is being used, so you're not going to just write O, okay? Or if I say that hydrogen is being used, you're not going to write H. No, this is wrong. Whenever I say oxygen, you're going to write O2. Whenever I say chlorine, bromine, iodine, fluorine, any of the gases, you're just going to write it in the gaseous form. Hydrogen, carbon dioxide, carbon monoxide. Okay, so these are some of the famous gases which we will be using in our syllabus. Yes, apart from this, we have the ammonia gas, which is the NH3 gas. Ammonia gas, NH3 gas. Then we have the sulfur dioxide. Di means 2. sulfur dioxide, sulfur trioxide, nitrogen dioxide. Okay, very commonly gases which you will be encountering in the various chemical reactions that we will be studying. So this is the list of gases. Whenever we say sulfur dioxide, sulfur trioxide, you should be instantly able to write their chemical formula without any hesitation. Okay, apart from this, water, H2O. I hope you all know this, but formality purpose I have put the formula of water also over here. Okay, next, apart from this, whenever I say any metal, I talk about any metal, name any metal, sodium, potassium, magnesium, aluminium. Whenever I say a metal is there in a particular reaction, for example, zinc reacts with copper sulfate, zinc reacts with sulfuric acid. So whenever I am naming the metal, I am going to just write the symbol of that element. So if I say sodium, then I write Na. If I say potassium, it is K. If I say magnesium, it is Mg. If I say aluminium, it is Al. If I say lithium, Li. Calcium, Ca. Barium, Ba. Copper, Cu. Lead, Pb. Iron, Fe. Okay, etc, etc, etc. All those elements that you see over here, these are all these cations that you are seeing, leave ammonium ion. Apart from that, whatever cations you are seeing, all of them are metals. So if I say any metal is there in a chemical reaction, you will write it as it is. The metal reaction you are going to write, in that particular metal reaction, you are going to write the element as it is. No doing this Na2, K2, Mg2 plus. No, this is wrong. You are not going to do this. Whenever we say metal, then directly the symbol you have to write it. Okay, this is how you are going to write the metals, and these are some of the famous gases and other compounds that I have listed down. Apart from this, few famous other chemical compounds as acids, you have to remember 3 or 4 majorly used acids. What are those majorly used acids? Number 1, hydrochloric acid. It's a wonder that so many students who are about to attempt their board exams very soon, maybe a month is just remaining, and if you ask them what is the formula, what is the hydrochloric acid, right? The formula of hydrochloric acid. Heartbreaking as a teacher to hear that they do not know what is the chemical formula of HCl, okay, or hydrochloric acid. So remember, hydrochloric acid is HCl, sulfuric acid is H2SO4, and nitric acid is HNO3. Apart from this, one more I'll write vinegar, since it is regularly used in your syllabus. Vinegar, or it is also called as acetic acid. Okay, CH3COOH. You'll be studying about acetic acid in detail in your carbon and compounds, right? So you should be knowing, but in case if you don't know, then remember at least 4 of these acids very well. Hydrochloric acid is HCl, sulfuric acid is H2SO4, nitric acid is HNO3, and vinegar or acetic acid, the other name of vinegar is acetic acid, okay, common name is acetic acid. It is CH3COOH, and out of these 3 are strong acids, and your CH3COOH is a weak acid. The reason why you are using it in the cooking purpose or as a preservative, you use vinegar, and you are able to use it because it is a weak acid. If it was a strong acid, obviously it's a corrosive chemical, so you will not be using it regularly in your day-to-day life. Okay, so hydrochloric acid, sulfuric acid, nitric acid, vinegar or acetic acid. In acids, remember this. Bases, very common base, which is nothing but sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide. In case if you are not able to remember this formulae, you should be remembering, because these are very commonly used. Again, I'm repeating, these are very commonly used. At least NaOH is so used everywhere. Okay. But in case if you have forgotten the formulae, then now we will be seeing how to write the chemical formulae of your cation and an anion, basically ionic compounds and all. Okay, so there you will get an idea how to write sodium hydroxide, potassium hydroxide, etc., etc. But you should be able to write these compounds without thinking about them much. Sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide, these are all bases. They are all strong bases. Okay, now you may ask, what is a weak base? Weak base is like a baking soda. Okay, or you can take your weak base as ammonium hydroxide, NH4OH, ammonium hydroxide. This is a weak base. At least one weak acid, one weak base, you remember, ammonium hydroxide. Fine. Again, pause the video, take a quick note of all these things what I've written: the gases, the metals, acids, bases. These are commonly used chemical compounds which you should be knowing. Okay, so write it down, learn them, and then proceed forward with the video. The next part of the video is how to write the chemical compounds. Okay, which chemical compounds? The chemical compounds which are made up of one cation and one anion. Okay, most of the chemical compounds that you have in your syllabus, forget about the organic chemistry part. I'm talking about the inorganic chemistry part which you have, which are the first 3 chapters. Most of the compounds are something either which come out of these list, or they are a combination of a cation and an anion from this list which I have given. So if this whole page is thorough to you, okay, you are very well versed with this page, then writing those compounds should not be an issue for you at all. Okay, now you may be asking, why, ma'am? Very simple. Okay, those who know about this, or those who have an idea about this, they will tell, oh, this is very simple, we already know it. Okay, for those who don't know, it is a very, very easy and a simple thing. Okay, say, for example, we have sodium chloride. We have a compound sodium chloride. Sodium chloride is dissolved with water. You have a reaction on that. Okay, just one random thing I'm telling. Sodium chloride is dissolved in water. Now, to write what is the chemical compound, what is the chemical formula of sodium chloride, what will you do? If you notice, see, this is a cation, chloride. See, again, it's not chlorine, it's chloride. So this is an anion. Whenever you have a chemical compound which is made up of one cation and one anion, what you are going to do is you are going to follow the method of crossing. You are going to cross the two compounds and write the chemical formula. How do we cross the compounds? Okay, now sodium. What is sodium? What is the cation of sodium? Remember, I am hoping that you had paused the video, learned the cations, and now you would have told that answer to me. Okay, I'm hoping that the answer was Na plus, right? Na plus. So write Na over here and write the charge over here +1. Okay, what we are going to write is the symbol over here and the charge over here +1. Next, chloride, what it is? Cl -1. Okay, cross this. What do I mean by crossing? Crossing means simply what you are going to write is you are going to write NaCl like this. You are going to put the charge of chlorine. Forget about the plus and minus. The number what is there over here. The charge of chlorine is going to be given to sodium, and the charge of sodium is going to be given to chlorine. Okay. So what is the charge of sodium? Now it will take the charge of chlorine, that is 1, and chlorine will take up the charge 1. So Na1Cl1. Okay, so now the chemical formula becomes NaCl. Wherever there is a 1, we do not write it. Okay, it is understood that there is one sodium and one chlorine. So now the chemical formula of sodium chloride is NaCl. As simple as that. Okay. Now, as I told you, sodium hydroxide, if you would have forgotten, you can easily cross it and find out, because why? Sodium hydroxide, one cation, one anion. Let me write here, sodium hydroxide. Okay. Okay. Cross it. Sodium is Na plus 1. Hydroxide is OH minus 1. Cross them. Na and OH. Na1, OH1. Ignore the ones, it becomes NaOH. See, sodium hydroxide. Same way, potassium hydroxide. Let's see for magnesium hydroxide. Okay, magnesium hydroxide. Okay, what is magnesium? Mg2 plus. What is hydroxide? OH minus 1. Correct? Now Mg is going to take this charge, OH is going to take this charge. So Mg1 OH. Remember, whenever there is a polyatomic ion, what are polyatomic ions? I have specified there, right? Which have more than one atom in it. Hydroxide has oxygen and hydrogen both in it, right? So whenever there is a polyatomic ion, what we are going to do is we are going to put it in a bracket if it has a charge. Like here, in sodium hydroxide, the charge was 1. We neglected it, right? So that time you can directly write it without the bracket. It is written without the bracket only. But when it takes up a charge, then you are going to put a bracket over here. Okay. So MgOH2, ignore the 1 and write it. It becomes MgOH2. MgOH2. Okay. Got it? And remember, now this means that how many magnesium, now this is the product, right? This is the compound that we got, magnesium hydroxide. In a magnesium hydroxide molecule, what you will be having is one atom of magnesium is there, and this 2 will get multiplied to everything that is there inside. So this means that there are 2 oxygen atoms and 2 hydrogen atoms. Understood? Let me repeat once again. In this magnesium hydroxide compound that we have written, in the molecule, there will be 1 magnesium, 2 oxygen, 2 hydrogen. Why am I specifying this here? I am specifying this here so that you remember it when you are going to balance the chemical reactions. Fine? Okay. Magnesium hydroxide. Let us write something else and see some other ones. Okay, I'm going to quickly erase this off here. Okay, what else can we write now? Let's take sodium carbonate. Again, a very commonly used compound, sodium carbonate. Okay, sodium is Na plus 1. Carbonate is CO3 2 minus. Again, as I indicated, 2 minus is the charge, not 3. Lot of students write this 3 here. No, this 3 is attached to this particular oxygen. Okay. Now cross them and write Na2CO3. I am not putting the bracket here because the charge is 1. Okay, so that 1 is ignored. Na2CO3, sodium carbonate. Now if I tell you sodium carbonate reacts with something, so you should be able to write this sodium carbonate by crossing it. Okay, and after some time, after you become so thorough with this compounds, after you have practiced a lot, this sodium carbonate comes directly without even crossing it. There's no need to cross it also. Okay, that should be the level of your chemistry. That should be the skill you acquire in chemistry, where you are able to write these compounds without actually crossing them. Fine. Nevertheless, if you have forgotten, then you can cross it out and check. So Na2CO3, and in this we have 2 atoms of sodium, 1 atom of carbon, 3 atoms of oxygen. Fine. One more, phosphate. Aluminium phosphate. Okay, aluminium is Al3 plus, phosphate is PO4 3 minus, cross them it becomes Al3 PO4. I hope you understood why I wrote the bracket now. 3. Now remember, whenever you take up the charges and there are same numbers over here 3 and 3, in that case also we will cancel them off and write AlPO4. Understood? AlPO4. If it is the same number, you are just going to strike it off and just write it directly. AlPl4. Let's take one more. Aluminium sulfate. Let's take this. Okay. Aluminium is Al3 plus, sulfate is SO4 2 minus, cross them Al2 SO4 thrice. Correct? So here how many aluminium atoms are there? 2. How many sulfur atoms are there? This 3 is multiplied to everything inside, right? So 3 is multiplied to S. So 3 sulfur atoms. How many oxygen atoms? 3 into 4, 12 oxygen atoms are present over here. Understood? This 3 is multiplied to everything which is there inside the bracket. So 3 sulfur atoms and total of 12 oxygen atoms. Apart from that, 2 aluminium atoms are also present. So this is the chemical formula of aluminium sulfate. Now I do not take anything more than this. Okay. Whatever was necessary to understand this topic, I have taken it up. Okay, so I hope we have spent almost about an hour on this itself, okay, on building your base. That's okay. So that the main purpose was that when you start with the chemical reactions, then you should find them easy and not difficult. Next, when I take up the reactions, I'm not going to explain at every step. If I say magnesium oxide, you should be able to write it. Okay, if you're not able to write the chemical formula, cross it and write. And I will not stop at every step and explain how to cross it. Okay, that is simply going to make it very tedious for you also, and especially for the students who already know all of these things. Okay, so I will leave it up to you. If in case you are not able to understand how a chemical formula has been derived, then you can definitely drop in the comment section and I will, help it out. I will answer it in the comment section there. Okay. Proceeding forward, next we will be seeing how to balance the chemical reactions. Balancing of few chemical reactions we will see, some 4 to 5, so that you get an idea as to how to quickly balance the chemical equations. And after that we will start with the revision, the proper revision of your syllabus, chemical reactions. And when I write the chemical reactions, let me tell you, I'm not going to explain, as I told, the crossing of this stuff. How did we get, why did I write H2O, why did I write H2Cl2? You should be understanding. I have given you the indication over here. Okay, so there we will be just writing the chemical reactions. Balancing also, you have to do it on your own. Okay, I'll give you the idea how to balance. Balancing of chemical equations you should be doing on your own. We will not be wasting time on balancing the chemical reactions. And also please do remember, in your board exams you have to balance the chemical equations, whether it is asked in the question or not asked in the question. It is a norm to balance every chemical reaction. You're going to lose marks if you do not balance the chemical reaction. So make it a habit to balance every chemical reaction that you write without fail. And do not keep balancing for last. Oh, at the end of the paper when I have time, I'm going to balance it. No. When you write the reaction, that particular point, you should balance it and leave it. Okay. And balancing, again, let me repeat, it is a skill which you have to pick up. It is not something you by heart. Very heartbreaking, very disappointing to see students balancing. Instead of balancing it, they are by hearting the balancing values. How are you going to remember it? And by God's grace, if you are able to remember that, then why not use such powerful brain such good memory power to actually remember the chemical reaction and other stuff. Why not put it to a good use? Okay, it's not normal to remember those all balanced chemical reactions, and if you remember, then you definitely have a very powerful mind, and you should use that mind to actually learn something useful and not mug up those reactions. Okay, proceeding forward to the next thing, which is nothing but balancing chemical reactions. We'll be proceeding to the next part, that is balancing of chemical equations. A lot of students still find, even the boards are quite near, they still find balancing of chemical equations a little bit difficult, or they are not able to balance. Okay, so what we will do is we'll do a quick revision of balancing the equations. Again, as I told for the previous part, if you are comfortable in balancing the chemical reactions, you know how to balance them and you do it quite well, then you can simply skip this part and go to the next part, where we will be actually starting with the chemical reactions. For those who do not know how to balance the chemical equations, or who are finding it difficult to balance the chemical equations, please continue the video from here itself. Okay, and I assure you, very soon, by the end of this topic, you will be able to balance the chemical equations well. Now, why do we balance the chemical equations? We balance the chemical equations because the law of conservation of mass states that mass can neither be created nor be destroyed in any chemical reaction. Okay, so the number of atoms that you had prior to the reactions and the number of atoms that you will have after the chemical reactions should be the same. So basically, whenever a chemical reaction takes place, the atoms rearrange themselves and form different compounds, but there is no new compound being formed, or no compound is being destroyed in a chemical reaction. Okay, that is the main concept of your law of conservation of mass, that in any chemical reactions, mass or atoms cannot be destroyed nor they can be created. The atoms will rearrange themselves to form the different compounds. Okay, now without any further delay, let us quickly dive into the concept of balancing equations. Balancing equations is nothing but you have to make sure all the atoms on the left hand side of your reaction and the right hand side of your reaction are equal. So let me take a very easy example. Magnesium plus oxygen reacts to form magnesium oxide. Okay, now how do you balance this particular equation? Okay, now see, first of all, in the very first step, identify what are the elements present in the left hand side and what is their count, and then identify what are the elements present on the right hand side and what is their count. What is the left hand side of the equation? Before the arrow, whatever is there, that is the left hand side. After the arrow, what is there, that is the right hand side. Okay, in the left hand side, what elements we have? Magnesium and oxygen. Okay, magnesium, oxygen over here. Left hand side, how many magnesium atoms? 1. How many oxygen atoms? 2. Okay. Right hand side, how many magnesium atoms? 1. Oxygen, 1. Now, if you see, the magnesium atoms are balanced. On the left hand side also you have 1 atom. On the right hand side also you have 1 atom. But oxygen is not balanced. You have to balance oxygen. Okay, so what we will do is, here there are 2 oxygen atoms, so we need to make 2 atoms over here also, so I'll put a number 2 over here. Always remember, when you are balancing the chemical reaction, you can write numbers before this elements or before the compounds, before the molecules itself. Okay, you cannot put the balancing numbers over here, no, always before the compound. Okay, before the compound or the element. So here I have written 2. Now this 2, again there's a confusion as to what does this 2 indicate. This 2 means this 2 is multiplied to each and every element that is present over here. So when I write 2 MgO, that means now on the right hand side we have 2 magnesium atoms, 2 oxygen atoms. Okay, so now what happened? You have balanced the oxygen, but the magnesium got unbalanced. Right? Now to balance magnesium, what will I have to do? I will have to just add a 2 over here. So this becomes 2 magnesium. Correct? So left hand side also 2, right hand side also 2. left hand side oxygen also 2, right hand side oxygen is also 2. So the balanced chemical reaction is 2 magnesium plus oxygen gives 2 magnesium oxide. As simple as that. Fine. Now this is a quite simple equation, and you need not do all of these steps for each of the reaction, writing the LHS, writing the RHS. This is for your understanding that I have written it down. Okay, once you get the hang of how to balance chemical equations, you can do it mentally itself. Okay, so this, if you are not thorough or if you are finding balancing difficult, first go by this method, LHS, RHS, you balance them. But once you are thorough, you get an idea of what actually is balancing, you can directly balance it over here. These steps are not necessary. Let's quickly take another example, a simple example. Okay, H2 plus O2 gives water. Hydrogen gas plus oxygen gas combines to give water. Okay, now left hand side, how many hydrogens do you have? 2. Right hand side, how many you have? 2. Okay, it's balanced. Oxygen 2, but here 1. So what we will do, we have to balance oxygen. We'll write 2 here. Okay, so now oxygen is balanced, 2 oxygen here, and as I told, this 2 will be multiplied here also, here also. So this 2 oxygen, this 2 oxygen, they are balanced. But what about hydrogen? Hydrogen has now become 4. You multiply these two numbers. To find the total hydrogen count, you'll have to multiply them. 2 into 2, 4. So there are 4 hydrogen here, and here there are only 2 hydrogen atoms. So to balance this, I will need to add a 2 over here. 2 2s are 4. Now see, 4 hydrogen, 2 oxygen. Here also 4 hydrogen, 2 oxygen, because this 2 is multiplied with the oxygen also. So this is the balanced chemical reaction. 2 hydrogen plus 1 oxygen reacts to give 2 water molecules. Let us take one more example. Al, aluminium, plus ferrous nitride, Fe3N2 gives aluminium nitride plus iron. Okay, so this is the chemical reaction. You have to balance it. Quite simple, just go on checking. Aluminium, 1 here, 1 here. Okay, balanced. Nitrogen, there are 2 over here, here only 1. So what I can do, I can put a 2 over here so that the nitrogen becomes balanced. Now see, you have balanced 2 nitrogen. Okay, here also there is 2 nitrogen. Nitrogen got balanced, but aluminium, it got disbalanced, right? 2 aluminium, so I can make this also 2. Now aluminium is also balanced. What is left? Iron. 3 iron over here, so 3 iron over here, and this is your balanced chemical equation. 2 aluminium plus ferrous nitride gives 2 aluminium nitride plus 3 iron element. Okay, now let us slightly raise the level and try to balance a different equation. Say now let me take another equation. NaClO3 decomposes NaCl plus O2. NaClO3 decomposes to give NaCl plus O2. Now identify how many elements are there. A lot of students do not know what elements are only present in a particular given compound. Okay, that shows that your chemistry really needs a lot of work. If you're not able to identify the elements present, then that means you really have to work on your chemistry concepts. And what you need to do is, first and foremost, you have to remember the first 20 elements in the periodic table along with their symbol order wise. Okay, with their atomic numbers, basically order wise with their symbols, so that you are able to identify the various elements. Okay, so now here you have 3 elements: sodium, chlorine, oxygen. Here sodium, chlorine, oxygen. Okay, one way of identifying the elements is from one capital letter to the next capital letter, whatever you have will be one element. So here Na, next capital is over here, right? So this is one element, one element, one element, like this. Fine. So NaClO3, here you have 3 elements, NaClO3. Here you have NaClO2. Now you have to balance. Okay, start Na, balanced, chlorine, balanced, but oxygen is not balanced. Here you have 3 oxygen, here you have 2 oxygens. How can you balance this? See, here what happened was, here there were 2 oxygens, here there was only one oxygen. You could just simply multiply by the number 2 to balance it. But here, can I multiply only one number at one place and make it equal? No, right? Because there are 3 here, 2 here. In such a situation, what you should be doing? In such a situation, the trick you can do is take the bigger number over here. See, oxygen we have 3, right? And here we have 2. Wherever oxygen is bigger, that side you pick it up and try to make this odd number as even number. Multiply this particular compound with a number such that this odd number becomes even. Okay. So if I multiply by 2, what happens? This becomes 3 2s are 6. Now to balance this 6 oxygen, I can multiply by 3 here. So it becomes 3 2s are 6. Another way you can see, or another way you can find the number to balance it, is by taking the product of these two numbers. 3 2s are 6. Right? So you need to get 6 oxygen here also, 6 oxygen here also. Sort of like LCM you're taking. Okay. So 2 3s are 6, 3 2s are 6. Now oxygen is balanced, right? But sodium and chlorine got unbalanced. You have to balance them. So 2Na, 2Cl. So I will multiply by 2 here. This makes it 2Na and 2Cl. Now this is a balanced chemical equation. Fine. Next, let me take up one more example, okay, of this type. H2O2, hydrogen peroxide, decomposes to form water plus oxygen. Hydrogen peroxide decomposes to form water plus oxygen. How do we balance this? Quickly check. Hydrogen 2, oxygen 2, but here oxygen is 3. Okay, there is odd number of oxygen here. Here it is even. Okay, now your purpose, as I told you, make sure that everything becomes even. Okay, when you make the number of atoms even, it is easier to balance on both the sides. Now what happened here? Here there are 2 atoms, here there are 3 atoms, right? Multiply by a number on this side so that the oxygens become even or balanced. Here see, there are already 2 oxygens. This is 1. This is the odd man out, right? I will just multiply by a 2 here so that this becomes 2 oxygen plus 2 oxygen, 4. Now it is an even number. It is easier to, balance the equation. What I have to do is just multiply by a 2 here. Correct? So now this makes it 2 into 2, 4 oxygen. Here you have 2 into oxygen, 2 oxygen plus 2 oxygen, total 4 oxygens this side. So oxygen is now balanced. What about hydrogen? 2 2s are 4, 2 2s are 4. Hydrogen also got balanced. So this is your balanced chemical equation. So the tip or the trick over here was that in case if oxygens are odd and even numbered, generally this happens with oxygen, hydrogen, okay, most of the time with the oxygens. Try to make sure that you have even number of oxygens on both the sides of the reaction. Multiply by a number such that the number of oxygen becomes even on both the sides, and then you can balance it easily. Okay, proceeding forward, another type of equation, let us take little bigger equation. Ammonium phosphate plus lead nitrate gives lead phosphate plus ammonium nitrate. This is a double displacement reaction. Pb 3PO4 4 times plus NH4NO3 ammonium nitrate. Okay, now first of all identify what and all atoms, what and all elements you can find here. Okay, here I will just draw the table, that LHS RHS table. Okay, you can balance it directly also. Let me first just draw the LHS RHS table so that you learn how to identify the elements. See here, first what we have? N, all the capital letters, till the capital letters you take one element. N, nitrogen 1, hydrogen, here next element, next phosphor, next oxygen, Pb, the next letter is here, capital letter is here, so Pb is one element which is nothing but lead. Okay, nitrogen you have already written, oxygen you have already written. So total there are 5 elements present here. Check it on this side. Do you have those 5 elements? Right, lead, phosphor, oxygen, nitrogen, hydrogen. Yes, 5 elements. Now count how many atoms of each of these elements are present on the left hand side and the right hand side. Nitrogen, here how many? See, whenever I write a number like this, for example, I am writing OH twice. Okay, whatever is there outside the bracket will get multiplied to each and every element inside the bracket. Remember, it is multiplied to only the elements present inside the bracket. Fine. Now here you see there is a 4 over here. This 4 is multiplied with this nitrogen also, this oxygen also. But this 4 is not multiplied with Pb. Do not make the mistake of multiplying it with Pb. Okay. Whatever is there outside the bracket gets multiplied to each and everything within the bracket. Okay, so now can you tell how many nitrogens are there here? N3. 3 nitrogens here plus here 4 nitrogens. So 3 plus 4, total of 7 nitrogens we have here. What about here? 2 nitrogens. 1, 2. 2 nitrogens, correct? Hydrogens, multiply this number to everything inside. So 3 4s are 12. There are 12 hydrogens over here. Okay, and what about the hydrogens here? 4 hydrogens, correct? What about phosphor? Here it is 1. Here it is multiplied by this 4, right? So there are 4 over here. Oxygen, 4 here, and here 3 4s are 12. 12 plus 4, total 16 oxygens you have here. Here 4 into 4, 16 plus this 3, total 19 oxygens are there. What about lead? 1 here, 3 here. 1 and 3. Now you have to balance this. Okay. Now here what happens is, lot of students think, how do you balance this? There are so many elements. Which elements do we take first? Because almost everything is unbalanced. Yes, all the elements are unbalanced. Which one to begin with? See, generally what you can do is you can begin with oxygen or you can begin with hydrogen. Okay, this helps. But in such a equation where you have, bracket type of compounds, one trick you can try before, actually trying to balance each and every element. One trick what you can try is treat this NH4 as one unit. Okay, treat this NH4 as one unit. NH4 here, total how many are there? Ammonium, how many are there total? 3. Right? So what I will do is I'll just write 3 here. Automatically the nitrogens here and here gets balanced. Getting my point? This nitrogens and this nitrogens will get balanced. This is one way you can try doing it, just to see if it works out. Okay. So here 3 are there. So I have multiplied by 3 over here. PO4, here how many are there? 4 PO4s are there, right? So I should be multiplying by 4 over here. Whole of PO4 are 4. So I am multiplying by 4 over here. But now what happened? When you multiplied this by 4, PO4 got balanced. The PO4 here is 4 and here it is 4. But what about ammonia now? Ammonium, it was 3 now, but because of this 4 it has become 4 3s are 12, right? So I need to make it 12. So on this portion what I will do is I'll just change the number and make it 12. This is one trick I'm trying to use to solve it. Okay, let's see if it works out. 12 I have done here. So 4 NH3, 4 12, here it is balanced. 4 PO4s are balanced. Here NH4 is balanced. NO3 now you see. Okay, NO3. NO3, how many are there? This whole NO3, 12 are there. Correct? Here how many are there? 4 are there. Also here lead, how many are there? 3. So I need to multiply by 3 here. So this 3 lead becomes 3 Pb, 3 Pb balanced. 3 into 4 NO3 groups, total 12 and 12. So now the equation should be balanced. Got it? What was the trick? Try to take this as one unit and solve. Thus ions what you have, try to take them as one unit and balance them. NH4, whole of it you balance together. Okay. So here total NH4 is 12. Here also 12. Treat them as one group and balance them as a group itself. It will reduce your work. Quickly see now whether it has balanced everything. How many nitrogens? Here
3, because this 3 is multiplied here, 3 nitrogen again multiplied by 4. So 12 nitrogen plus here how many? 4 into 3, 12 again. So total 12 plus 12, 24 nitrogens. What about here? You have N here, 2 N's over here, 2 nitrogens, and again multiplied by 12. So this became 24. See, nitrogen got balanced. What about hydrogen? 3 4s are 12, 12 4s are 48. What about this? 12 4s are 48. Yes, hydrogen also got balanced. Now see how big these numbers are. If you would have tried to put numbers and for each of them without taking them as units, how difficult would it be just to find the balancing numbers? So this is a very good and easy trick. We'll take one more example and see how to do it. So you'll get a better hang of it. Phosphor, just quickly count. 1 over here and 4 multiplied, so it is 4. And here also 4 is multiplied, so 4 and 4. What about oxygen? 4 into 4, 16 plus 3 4s are 12. 16 plus 12 into 3, 36. 52 oxygens are there here. And what about here? 4 4s are 16. 16 plus 12 into 3, 36. Right? 52. So 52 oxygen. Oxygen is also balanced. What about lead? 3 lead over here, 3 lead over here. So lead is also balanced. Everything is balanced now. As simple as that. Easy peasy. Let's just take one more example of balancing and then we'll come to the actual syllabus. Okay. Let me take another example. Say BF3. Boron fluoride. Boron fluoride plus lithium sulfide gives boron sulfide plus lithium fluoride. Okay, so this is what you have to balance. Now what are the elements here? Boron, fluorine, lithium, sulfur, oxygen. Here also same ones. Now how do I balance them? Okay, try to take units and balance. Now see here SO3, take it as 1 unit. How many SO3s are there here? 3. So I'll just multiply by 3 here so that this whole SO3 becomes 3 here also, here also. Okay. Next, what about lithium? 3 into 2, 6. So I'll make this 6. 6 Li and here also we have 6 Li. So this whole thing is balanced now. What about fluorine here? Here it is 6 fluorine. Here it is 3 fluorine. So if I multiply by 2, 2 3s are 6. 6 fluorine, 6 fluorine here. And boron, 2 boron here, 2 boron here. See, quite easily you could balance it. So this is one very nice trick of solving your chemical equations quite quickly. I hope this is clear now. If you have any doubts, any queries, please feel free to drop it in the comment sections and I'll be glad to clear those for you. So now students, we are finally ready to begin with the chemical reactions of your syllabus, starting with the very first chapter, chemical reactions and equations. Brace up yourselves, fasten your seat belts and embark on this journey with me, and I assure you that by the end of this video, you will be thorough with all the chemical reactions and you will feel that you have completed your revision with all the necessary points being highlighted. But remember, the condition is that you have to take a pen, a book and sit down and write down the reactions with me. Even if you think that you're just here to revise, write down the equations at least once. Okay, make your notes. As you proceed forward with this particular video, please make your notes, write down the chemical reactions, and I will be stating the key words. Okay, the keywords of each reaction, write down those keywords. You need not write whole sentences on it because right now you are here for revision. Just write down the keywords and highlight them so that before your exams, okay, when you are going to get your study holidays, you just have to open this book, these sheets where you will be writing the reactions, see the keywords, and your revision will be done in no time. beginning with the very first chemical reaction given in your textbooks in the NCERT, right? We are currently following the NCERT. The first equation that you have in your syllabus is the burning of magnesium ribbon in air. Burning of magnesium ribbon. Give the heading in your notebooks quickly along with me. Burning of magnesium ribbon. So, you know, there's an activity also stated in the textbook wherein you take a magnesium paper, a magnesium ribbon, right? And what we do is we rub it with sandpaper and then burn it in air and oxygen. So the reaction goes that magnesium plus oxygen burns in air to give magnesium oxide. Now, I will not be doing this in every reaction, but as I told in the starting part of the video where we revised with the basics, whenever I say a metal, for example magnesium, then you will just write the symbol of the element. And when we say something is burning, okay, so always remember it means that it is going to react with the oxygen in the air. Okay, when we say something burns in air, it simply means that you have to write oxygen in the reactant side. Okay, burning means that the element, the compound is going to react with the oxygen present in air to give a particular product. Okay, so now here magnesium ribbon, when it burns in air, it burns with a dazzling white flame to give a white colored powder. Okay, and the reaction is magnesium plus oxygen gives magnesium oxide. Now, how do you write magnesium oxide? A lot of students, what they do is they just write like this, MgO2. No. Remember, whenever there is a cation and an anion, magnesium oxide, two things are combining to form something. I told refer to the ions list. Magnesium is +2, oxygen is -2. Cross them, you're going to get Mg2 O2, same numbers, cancel them off, the compound is magnesium oxide. So in case if you forget the chemical formula, what you will be doing is you will be crossing them and then writing the chemical reaction. This way, I assure you that your chemical reactions will not go wrong. Now, if you want to balance this equation, quite simple. You see 2 oxygen here, you put a 2 over here and a 2 over here, the reaction is also balanced. So half of the worries that you have in chemistry, we do not know how to write the compounds, we forget the compound names, we do not know how to balance the chemical reactions. All of those is covered in the previous portion of this video, right? The previous part of the video was to make sure that you do not worry about this anymore. Okay, now all that you have to do is focus on the concepts and try to remember what are the reactants and the products. Not to worry how to write the chemical formula, how to balance them. No, you are here to study the reactions. You're supposed to focus on the reactions, not on the basics of chemistry. So once again, let us come back quickly. I just gave you a short tip over here how to apply those concepts what you have learned in the previous part of the video, so that from next equation onwards you are able to write the compounds on your own and you are able to balance them on your own and not worry about them. Okay, so the very first equation is the burning of magnesium ribbon. Magnesium metal is generally present in the laboratories in the form of a ribbon, a small strip of paper, okay, or it is present in the form of a wire. And what generally magnesium has is it will have a shining surface because it is a metal, right? It will have a shining surface, but when you expose it to air, due to the presence of moist air, what happens is magnesium reacts with the oxygen in the air. Okay, it reacts with the moist air and it gets coated with a layer of magnesium oxide. I'm not writing all of these points you should be knowing. Just listen to me, and the key points, just the key words, you keep writing them down. Okay, magnesium strip has a shiny surface. It reacts with the moisture in the air and develops a thin coating on it. A thin white layer is present on those metal strips that are present in the laboratory. What is that white color layer that is formed? That white color layer is nothing but magnesium oxide. Now this magnesium oxide layer, while a strip if you take and try to burn it, you will not be able to perform the experiment. Okay, that will not burn. Why? Because there is a layer of magnesium oxide on it. Now if you want the pure magnesium which you are going to burn it, for your experiment, which you are going to burn it, which is this particular reaction, first you need to clean it. There is a magnesium oxide layer present on the magnesium strip. You need to remove this. How will you remove this? You are going to remove it with the help of a sandpaper. You are going to rub it with the sandpaper so that the magnesium oxide layer is removed and you get pure magnesium. That pure magnesium, when you burn it in air, when you burn it in the presence of oxygen, what will happen? The magnesium will react with oxygen to form magnesium oxide. What is the speciality of this reaction? The speciality of this reaction is that it gives a dazzling white flame. A beautiful white color flame is observed. And what is the end product of this reaction? End product is that magnesium oxide, which is nothing but a white colored powder, will be obtained. This reaction, when it is taking place, when you are burning it, it is going to be burnt with a dazzling white flame and you get a white color product at the end, which is nothing but your magnesium oxide. Okay, and remember the dazzling light, it is so dazzling, so bright that it can be harmful to the eyes. Hence, generally when you perform the experiment, you keep it a little far away from you. Now, what are the possible type of questions that may come? How does magnesium ribbon burn in air? Okay, this is a very straightforward question. Straightforward questions I am sure you will be able to do. But you may get this question as a concept based question also, where you have to apply the concept. Okay, the same question, instead of asking how does magnesium ribbon burn in air, what the boards will do is, in the paper they are going to ask the question something like this. A metal X on burning in air burns with a dazzling white flame to produce a white colored compound Y. Identify X, identify Y, write the chemical reaction for the same. Okay. Then they may ask the same question like this also. The same metal X, when kept in moist air for a long time, develops a white layer on it of compound, say Z. Identify Z. How can you remove the layer of Z from the metal X? This also can be the question. So now here, if it comes in the form of X, Y, Z, you do not have to worry, oh my god, how are we going to identify X, Y, Z? No, there will be the keywords. What I was telling you right now, write the keywords. In front of every equation, write the keywords. If this keyword comes, blindly you can write the this particular reaction what you are studying. For example, in this, what are the keywords? Dazzling white flame. This is the keyword of this reaction. Okay, the minute you see in the question paper dazzling white flame, it does not matter what is before it, what is after it, it is definitely this reaction. Because in your whole syllabus, the reaction with the dazzling white flame that you have is this only one particular reaction. Okay, so the keyword over here is dazzling white flame, and one more indication what is given to you, that it produces a white color compound. This also is a keyword which indicates that this is magnesium oxide. This is how you will identify the compounds. Okay, so quickly note the keywords for this reaction. You have a strip, metal strip. Okay, the keyword is dazzling white flame and a white color compound. Also, that developing a thin layer, they may ask you question about why magnesium ribbon should be cleaned with a sandpaper. Okay, so this sandpaper cleaning is another keyword which is related to this reaction. Now I have explained the concept behind why we use the sandpaper to clean the magnesium ribbon. Why? Because it develops a thin layer of magnesium oxide which will prevent it from burning. So to enable burning, we first clean it with sandpaper and then burn it. Okay, so this is all about the magnesium ribbon that you should be remembering. Again, as I told you, I'm repeating this again and again so that you learn the procedure of how to study for your boards, how to revise for your boards. Write the heading, burning of magnesium ribbon, write the reaction. If you balance it now, well and good, balance it so that you get a habit of balancing the chemical reactions. Okay, but do not remember it, the reaction like 2 magnesium plus oxygen gives magnesium oxide, 2 magnesium oxide. No, you just have to remember magnesium plus oxygen gives me magnesium oxide. Everything else I should be able to write on my own. Fine. And the keywords: sandpaper, dazzling white flame, white color compound. These are the 3 keywords you will be mentioning in front of it. Done? Done. Okay, one more point you can write in front of it is, what type of reaction is this? Okay, they may ask you magnesium burns, right, in oxygen to give you magnesium oxide. What type of reaction is it? You have studied the different types of reaction: combination reaction, decomposition reaction, exothermic reaction, endothermic reaction, oxidation reactions, reduction reactions, redox reactions, right? A number of reactions you have studied. So what is this type of reaction? Do one thing, write what type of reaction it is also in front of it, so that once you go through it when you are revising before your boards. Okay, so magnesium plus oxygen combines to give you magnesium oxide. Two reactants are combining to form one product. Okay, so this is nothing but a combination reaction, right, where magnesium and oxygen combine to form magnesium oxide. Next, what other type of reaction can you name it? This is an oxidation reaction also, where magnesium is getting oxidized to magnesium oxide because an oxygen is being added to magnesium over here. So this can be an example of oxidation reaction also. Plus, this is an example of exothermic reaction also. What are exothermic reactions? Reactions which give out heat, which give out light, which give out energy are the reactions which are exothermic reactions. Now, since here it produces a dazzling white flame, it is giving out heat, it is giving out light, it is giving out energy. So we say that this is an exothermic reaction. Okay, so this can be an example for combination reaction, oxidation reaction, as well as an exothermic reaction. Done? Now it's completely done. Fine. Let us proceed to the next equation, which is nothing but the golden rain reaction. Now this is also present in your textbook as an activity. The second activity in your textbook is this golden rain reaction, though the name might not be present there, that it is the golden rain reaction. So here what do? You take the solution of lead nitrate in one test tube, and in another test tube you take potassium iodide solution, and then you mix them. When you mix the two solutions, you will observe that a yellow color precipitate will appear, a golden yellow precipitate will appear. Okay, that is why it is called as a golden rain reaction, yellow color precipitate. Okay, this yellow precipitate is nothing but lead iodide, and we have another solution. Okay, another solution also is obtained, which is nothing but potassium nitrate. Again, it is colorless, so you will not be able to see its color. Okay, so this also may come as an X and Y reaction. A solution of X and Y is combined and you get two products, Y and Z, where Y is a yellow precipitate. This yellow precipitate should give you an idea that this is the golden rain reaction. The yellow precipitate is the keyword over here. Okay, so what is the reaction? The reaction is that lead nitrate plus potassium iodide. What is lead nitrate? Lead nitrate. Cross them and write. Okay, lead nitrate, PbNO3 twice, plus potassium iodide. Again, potassium iodide you can cross and write. You only have to remember the reactants over here, lead nitrate and potassium iodide. How will you write the products? You can write the products on your own. Why? Because this is a double displacement reaction. So lead will take iodide and combine and form lead iodide, plus nitrate and this potassium will combine and form potassium nitrate. Now this lead iodide, mark this, highlight this and keep. This is yellow in color. Which one? This potassium iodide is yellow or golden yellow in color, which is a precipitate, yellow precipitate. This is the key word. If it is given two colorless solutions react to give you a yellow precipitate and a colorless solution. This is colorless, this has no color. This is colorless, this is colorless, and this is also colorless. Okay, the yellow precipitate should give you an indication that this is a golden rain reaction. To remember this reaction, you have to only remember lead nitrate and potassium iodide. You'll just simply cross off the ions with one another and write the compound. So lead will take up iodine, and potassium will take this nitrate, and together you will form the lead iodide and potassium nitrate solution. Again, keyword here is the yellow precipitate. Okay, what type of reaction is this now? This is a double displacement reaction. Why? Because the ions are getting exchanged, right? So this is a double displacement reaction. They may ask you to write the reaction, balance the reaction, identify X, Y, Z, and also identify what type of reaction this is. Remember, this is a simple double displacement reaction. How do you know this is a double displacement reaction? Prove that this is a double displacement reaction. This also might be a question. You have to answer that the precipitate that is formed, the yellow precipitate that is formed, indicates that this is a double displacement reaction, because in double displacement reactions we generally get a precipitate. So here the formation of precipitate proves that or justifies that it is a double displacement reaction. Okay, so this precipitate, you can just mark it that this justifies that it is a double displacement reaction. So these are the keywords you should be noting: double displacement, justifies, yellow precipitate. Okay, I hope that is clear now. Your second reaction of the chapter is also complete. Proceeding forward, the next equation is the reaction between zinc and dilute sulfuric acid. Okay, so zinc plus acid reaction. This will again come in your next chapter, acids, bases and salts. Okay, but here, since it is present as an activity, let me just quickly explain what it is. So what you are going to do is you are going to take a few granulated zinc pieces, okay, small granules of zinc in a conical flask, and you are going to add an acid, a dilute acid like sulfuric acid or maybe hydrochloric acid, and then we will observe the reaction. So what happens? This zinc and this sulfuric acid will react and they will form a salt, plus hydrogen gas will be released. And what it is observed that on the surface of the zinc pieces, small bubbles will be coming. Why am I telling these words? Because these will be given in your application based questions. Okay, so if this is one piece of zinc, one granule of zinc, when you add sulfuric acid to it or hydrochloric acid to it, small bubbles will start appearing. Okay, and you will see a gas and you will see a gas being briskly evolved. What do I mean by briskly evolved? Means very quickly a gas is being evolved. Okay, and what happens is when you pass this gas, whatever gas is being evolved, if you pass it out through a glass tube, and if you bring a candle near the gas will burn with a pop sound. The gas is going to burn with a pop sound. Okay, so this indicates the presence of the hydrogen gas. Now quickly let me just write the reaction over here. So zinc plus sulfuric acid, again I have told you already, you have to remember the formula of sulfuric acid, H2SO4 will give me, common sense tells me that zinc will react with sulfate, so it will form zinc sulfate. Okay, plus this hydrogen gas will be released. Again, in the next chapter we will study the general reaction that any metal plus acid will give me the salt of that particular metal, plus hydrogen gas will be evolved. So this is just one example of that. Okay, so now here this is your reaction. Zinc plus sulfuric acid gives you zinc sulfate plus hydrogen. Very easy to remember, a very common sense type of reaction to remember. Okay, because zinc will combine with zinc sulfate to form zinc sulfate, and hydrogen gas will be released. Now what are the keywords? Again, what are the keywords that you have to remember? One thing is that bubbles start coming up on the surface of zinc granule. Bubbles appear on surface. Okay, so this is one keyword you should be remembering. Second thing is a gas is briskly evolved. So this is the second keyword you should be remembering. Third keyword is that the gas will burn with a popping sound. Remember, whenever it is said that any gas is being burnt with a popping sound, or when a candle is brought near it, it burns with a popping sound. Okay, you have to understand that this is hydrogen gas only. Okay, you can easily identify that this is the hydrogen gas. Okay, so you may get that a few pieces of or a few granules of metal X is reacted with a acid Y. It produces a gas, okay, or it releases a gas. Gas is briskly evolved, which when you bring a candle near to it, burns with a popping sound. Okay, identify the metal X, identify the metal Y, also identify the gas Z, which burns with the popping sound, something like that. These type of reactions they will be asking you, but these are the keywords. When you see these keywords, popping sound, brisk gas evolved, small bubbles appearing on the surface, you have to understand this is the zinc plus the sulfuric acid reaction. So you have to write the reaction, balance it, and maybe explain about it. Now, what other things can you tell about this reaction? What type of reaction is this? This is the reaction of a metal plus acid, which gives a salt plus hydrogen gases released. So this is a metal plus acid type of reaction. Okay, apart from that, what can we tell? We can tell that this is an exothermic reaction. Okay, most of the reactions which involve an acid in them will be an exothermic reactions, because they react very vigorously. They react with a lot of heat being produced. So if you perform this experiment in the lab, and if you touch the conical flask once the reaction has taken place, you will see that it has become warm. It will become warm. Why? Because this is an exothermic reaction. Okay. So if they ask what type of reaction it is, you can mention that it is an exothermic type of reaction. So this is the third reaction in your syllabus. Okay, next reaction in your NCERT, under the balancing of equations, it is given. Okay, it is about the iron oxide. Fine. Now this you will get it again in your third chapter, where you're talking about metals, non-metals, electrolysis, everything you will learn about it there, right? So in that chapter you have these reactions about how iron reacts with steam, how magnesium reacts with water, whether it reacts with cold water, hot water, all of those reactions are there. Okay, but now since it is a part of your textbook, it is present in the textbook, I will include it here itself. Okay, so this is the reaction of iron with steam. Okay, when steam is passed over heated iron, then what do we get? We get a magnetic oxide of iron. Magnetic oxide of iron. It's a very simple reaction actually. It is nothing but iron. Heated iron means it is iron only, right? So iron plus steam. What is steam? Water, but in the gaseous state, right? So it is, steam is nothing but water. So iron plus water gives you iron oxide. This is Fe3O4. Remember, it is Fe3O4, which is nothing but the magnetic oxide of iron. Now what is the magnetic oxide of iron? I'll come to it. Apart from this, what will be released? H2 will be released. So heated iron, when you pass steam through it, okay, so iron plus water. Why iron? Because that is the reaction. Why water? Because steam is a form of water. Okay, so iron plus steam gives you magnetic oxide of iron plus hydrogen gas will be released. Now common sense tells us that, right? So if this is forming iron oxide, what is left? Hydrogen is left, right? So it has to evolve as hydrogen gas. So hydrogen gas is evolved. Now remember, what do I mean by magnetic oxide of iron? It means that, see, actually there are 3 oxides of iron. Iron has 3 oxide. Okay, the first oxide of iron is nothing but ferrous oxide. If you cross it and write ferrous oxide, you will get the formula FeO. This is the first type of oxide of iron. Second one is ferric oxide. Ferric oxide, if you cross it, okay, you will get Fe2O3. Ferrous oxide, ferric oxide. Fine. Now when you have a mixture of both of this, ferrous oxide plus ferric oxide together, you get the magnetic oxide of iron, which is nothing but Fe2O3. Okay, so it is like a double oxide of iron. Now what they may ask you about this reaction, again an X and Y type of question, or sometimes it is asked in this type of form also. Write the balanced chemical equation for the reaction when steam is passed over heated iron to form magnetic oxide of iron and hydrogen. So this also they may ask it, where they give it in sentence and you have to frame it in the equation form. That is, you have to write this equation form. So what are the keywords here? Steam, hot iron, magnetic oxide of iron. Okay, and magnetic oxide is nothing but Fe3O4. So these are the keywords for this particular reaction. I hope this is clear now. Let us quickly proceed to the next equation, which is the combination reaction of quicklime. Okay, combination reaction, and this is the quicklime reaction, a very important reaction. You can star mark it a number of times because this is asked so many times in boards. That is almost a sure question. Okay, so very commonly asked reaction this is. Okay, so here what do you have? The quicklime reaction. You know that quicklime reacts with water to produce slaked lime and a large amount of heat is released. So this is a combination reaction where calcium oxide is nothing but your quicklime. Quicklime reacts with water, so means I have to do H2O, right? Quicklime is calcium oxide. It reacts with water to form slaked lime. Now what is slaked lime? It is calcium hydroxide. Okay, calcium hydroxide, calcium plus water, right? So calcium hydroxide. Because this is a combination reaction, you are going to get only one product over here, but this is an highly exothermic reaction, so a lot of heat is produced. Okay, so now this calcium hydroxide is also known as slaked lime. You have to remember these names also, the common names, quicklime and slaked lime. Okay, so what are the keywords of this reaction which you have to remember? It is a combination reaction. Okay, also this is an example of exothermic reaction. This is an example of exothermic reaction. Okay, here one more word you can remember as a keyword is that there is a vigorous reaction. Okay, calcium oxide reacts with water vigorously. So this is also a keyword. Now this slaked lime that you have gotten over here, calcium hydroxide that you have gotten over here, this is used for whitewashing the walls, right? So whitewashing is another keyword which they will definitely mention in the question if it is regarding this particular reaction. Okay, so if you have to write this reaction, they will definitely mention that it is used for whitewashing the walls. That is the keyword. So if it is a whitewashing reaction, you will have to write first this reaction, calcium oxide plus water giving you calcium hydroxide. Then we are using the solution of calcium hydroxide to whitewash the walls, right? So you have to write the second reaction also. Now what is the second reaction? The second reaction is nothing but what happens is when you use a solution of slaked lime, okay, this you are using it to whitewash the walls. So this will, using this we will paint the walls, we will whitewash the walls and leave it. Okay, now what is present in the atmosphere? Carbon dioxide is present in the atmosphere. So this particular whitewashed walls, that is the slaked lime, will react with the carbon dioxide present in the atmosphere to form calcium carbonate. Okay, and water will be released. Okay, so this calcium carbonate gives you the shiny finish to the walls. Okay, and this is also present in marble. So these are the keywords you should be writing: whitewashed, marble, shiny finished. Okay, so whitewashing, anything regarding whitewashing, if they say, you are going to write this reaction. First, calcium oxide reacts with water to form slaked lime. Then slaked lime reacts with the carbon dioxide in the air to form the whitewashed walls, which is nothing but calcium carbonate, and water is also released in this particular reaction. Fine. The keywords are also done. Let us proceed forward now to the next reaction. The sixth reaction. Which is the sixth reaction? The sixth reaction is a few more example of your combination reactions, right? So burning of coal. Coal is what? Coal is nothing but carbon, right? So carbon will burn. As I told you, burning means it is always oxygen. So carbon will burn in oxygen to give you what? Carbon dioxide. Okay. So this is the reaction of burning of coal. Very simple. Coal is carbon. Okay, next, what is the type of reaction over here? This is a exothermic reaction as well as a combination reaction. Correct? Next, formation of water. Water is formed from what? Hydrogen plus oxygen. They will combine to form water. So again, this is your combination reaction. Okay. So this is the formation of water. I think these are very simple equations. All of you would be knowing it. So I am quickly proceeding forward. The next one what we have is the burning of natural gas. What is natural gas? You should remember that CH4 is the natural gas, which is nothing but methane. Okay. Methane, this is also called as natural gas. Methane, you are burning it. Burning means adding oxygen to it. Remember, any carbon compound, this is a general rule, you take it. Any hydrocarbon, if you are going to burn it in oxygen, okay, burn it in the presence of oxygen, you are burning it, okay, it will produce carbon dioxide and water will be released in the particular reaction. This is the standard or the general one. Any carbon compound, if you are burning in oxygen, you are going to get carbon dioxide and water. Any hydrocarbon. Okay. So carbon dioxide will be produced and released. Fine. So this is the natural gas reaction where you are doing an exothermic reaction. What type of reaction this is? This is an exothermic reaction. Now what other reactions are given in your syllabus? It is given that respiration is also a exothermic reaction. So they may ask about respiration. Okay, so remember always respiration is an exothermic reaction and you should write the chemical reaction for respiration. In respiration what happens? Glucose is burnt. Okay, what I am saying, remember the words as it is. Glucose is burnt. Now what is glucose? C6H12O6, 612 6. Okay, C6H12O6. This is your glucose. Now what did I tell? You are burning glucose. In respiration, what basically you are doing? You must have studied in biology. Respiration means what? You are burning the glucose present in your body. Whatever you eat from the carbohydrates, what glucose you are getting in your body, that you are burning to get energy. Right? So, this is glucose. This is glucose. You are burning it means you will react it with oxygen. To give what? What did I just tell you? Any carbon compound, if you burn it in oxygen, what are you supposed to get? You are supposed to get carbon dioxide, you are supposed to get water, and you will get lots of energy. That is why you are respiring, right? You are supposed to get the energy. And that is why it is an exothermic reaction also, because it is releasing energy. Okay, it will release energy and this is the energy what you will be using. So respiration is an exothermic process where you are burning glucose. Just remember this much. Respiration means burning glucose. Now you should know the glucose formula, C6H12O6. Burning means just click it like that. Burning means I have to add oxygen. When I add oxygen, what will happen to any carbon compound? If you are burning it in the presence of oxygen, we have to get carbon dioxide and water over here. Okay, hydrocarbons will give you carbon dioxide and water. So you have gotten carbon dioxide and water, and because this is an exothermic process, we are going to get lots of energy, and this is the energy we are using for our different functions of the body. Okay, whatever oxygen your body needs is given by this process of respiration. So this is a link between your biology and a chemical reaction. Next, decomposition of vegetable matter is also a exothermic reaction. Fine, there's no reaction for it. You just have to know that it is an example of exothermic reaction. Might come as a MCQ type of question. Next, equation number 10. Equation number 10, it is the decomposition reaction of ferrous sulfate. Your activity number 5, okay, ferrous sulfate decomposition reaction. Decomposition reaction. Now remember here what you will be doing is you are going to take ferrous sulfate. Okay, ferrous sulfate is in the crystal form. These crystals are green in color. You can take them, you can think that they are light green in color. Okay, so when you take them in a test tube, in a boiling tube, and you heat them, what happens is first you will see that the green color of the crystals is gone. It becomes a white colored compound. And if you further heat it, you will see that you will have the smell of, you will get a burning smell, sulfur burning smell. What is this sulfur burning smell? Have you seen the tire burning smell? Car tires, when they skid on the road, or if there is a tire burning, you get that smell, right? So that is the smell of burning sulfur. Okay, so what happens in ferrous sulfate is first the green color is lost. Okay, you'll get a white color compound. Further, if you heat it, you're going to get the burning smell of sulfur. Okay, or you'll get a false bad smelling gases. So in your questions it is given like that you will get bad smelling gases. X is a compound which when heating loses green color, and on further heating produces bad smelling compounds, bad smelling gases. Okay, so that green color compound which when heating produces bad smelling gases, okay, produces the smell of burning sulfur, something like that if they say, then you have to understand it is this equation only, cannot be anything else. In your syllabus what you have, green color compound loses its green color, that itself is the keyword to understand that it is this particular reaction. Okay, so quickly write the keywords. It is green in color, okay, color lost on heating, lost on heating, plus bad smelling gases, this could be the thing, okay, or burning of sulfur smell you will get, or suffocating gases, something like this will be given. Okay, so these are the key words you will be getting. Okay, so green color compound on heating loses the green color, bad smelling gases, burning of sulfur, suffocating gases, such terms will be used. So you have to understand it is this particular reaction. Now first understand ferrous sulfate. Okay, ferrous sulfate is FeSO4. It has 7 molecules of water attached with it. This is the key here. Okay, remember it has 7 molecules of waters attached to it. This will come in the next chapter also, right, where you study about water of crystallization. But here it is a part of this reaction, that is why I am explaining it here only. There are 7 molecules of water attached with ferrous sulfate. These 7 water molecules are nothing but they are called as water of crystallization. Water of crystallization. Whenever there is this water of crystallization with ferrous sulfate, it will have the color. It will have the color. Where is this green color coming from? This green color is coming from the water of crystallization. Now what happens when I heat it? When I heat ferrous sulfate, it will lose this water of crystallization. It's water, na? It will evaporate and go away, right? So ferrous sulfate, which is having 7 molecules of water as water of crystallization, when you heat it, heating is shown by the small triangle delta. When you heat it, what will happen? It will form ferrous sulfate plus these 7 molecules of water are lost. They are evaporated. Okay, they will be lost. Next, what happens? This is white in color. It was earlier green in color, it lost the green color, okay, and it formed a white color compound. Why? Because it lost the water of crystallization. Okay, now what happens when I further heat it? This FeSO4, if I still heat it, it will decompose to form ferric oxide plus bad smelling gases are nothing but your sulfur dioxide and sulfur trioxide. Both of them are gases which will be released. So I think now you can easily identify what is X, what is Y, what are the bad smelling compounds. Okay, quite easy to understand. And if they ask any question regarding this, you have to write both the equations. Okay, so ferrous sulfate, when you are heating it, it loses the 7 molecules of water of crystallization and becomes white in color. If you further heat it, it will decompose into ferric oxide, and 2 gases, sulfur dioxide and sulfur trioxide, are released. Now, what else do you have to remember about this reaction? What type of reaction is this? This is a decomposition reaction. What type of decomposition reaction is this? It's just simply decomposition reaction. In decomposition also you have different type of decomposition reactions. This is the thermal decomposition reaction, means the decomposition here occurs because of the heat. Thermal means heat. So this is a thermal decomposition reaction. Next, what other type of reaction is this? This is an endothermic reaction. This is an endothermic reaction. Why is it an endothermic reaction? What are endothermic reactions? Endothermic reactions are those reactions which take up energy, which take up heat, which take up other forms of energy, which take energy and they will decompose. Okay, so here one compound is getting decomposed into multiple compounds. That is why it is a decomposition reaction. Because of heat it is decomposing, so it is a thermal decomposition reaction. And because it is taking up energy, it is taking up heat, and then the reaction is getting occurring, right? So it is an endothermic reaction. Now you can put a note over here and write it and keep that this is a general rule. What is the general rule? The general rule states that all combination reactions are generally exothermic in nature, and all the decomposition reactions are endothermic in nature. If you identify what type of reaction it is, whether it is a combination reaction, decomposition reaction, you can remember this way also. Exothermic reactions, your combination reactions will be exothermic in nature, that is they will be giving out heat, and your decomposition reactions are endothermic in nature, that is they will be taking up your energy. Okay. Next reaction is another example of your decomposition reaction and thermal decomposition reaction. It is the reaction which is used in cement industry, in the manufacture of cement. So if you get a question regarding manufacturing of cement, the word cement if you see, then it has to be this reaction. The calcium carbonate, whitewashing we studied, right? Calcium carbonate is formed. This calcium carbonate, if you heat it, okay, thermally it will get decomposed into what? Calcium oxide plus carbon dioxide. You are going to get this quick line back. Okay, this calcium carbonate is also known as limestone. It is present in limestone. Limestone is made up of calcium carbonate, limestone, marble, whatever. So these words also you may get to indicate that this is calcium carbonate. Okay, so this is again a keyword. Okay, and the keyword for this particular reaction, the main keyword is cement. This word will be present. So if anything relating to manufacturing of cement is there, then you will write this reaction, that calcium carbonate decomposes to form calcium oxide plus carbon dioxide, and carbon dioxide is released. Okay, and about carbon dioxide they may tell that this gas, when it is passed through lime water, the lime water turns milky. Okay, so brisk effervescence, lime water turns milky. This is the key to understand. Just like I told, popping sound is the key to understand that it is the hydrogen gas, your lime water turning milky, and excess of gas when it is passed, the milkiness going away. Okay, in excess the milkiness vanishes. Okay, then this is an indication, these keywords are an indication that this is the carbon dioxide gas. Now even if you forget the reaction, you should at least remember this word, lime water turning milky means carbon dioxide only. Blindly you can write carbon dioxide and Ca. Okay, so this is the next equation. Cement, manufacturing of cement, where it is used. Again, what type of reaction is this? This is a thermal decomposition reaction, and as I told you, all decomposition reactions are endothermic in nature, so this is also an endothermic reaction. That's it about this particular equation. Let us come to the next equation, the 12th equation. The 12th equation is regarding one more thermal decomposition, which is in your activity number 6, where you are taking lead nitrate and you are heating it. What is lead nitrate? Okay, heating of lead nitrate. Okay, let us write the reaction. What is lead nitrate? Lead nitrate, cross and write lead nitrate. Okay, lead is 2, nitrate 1, cross it, you will get lead nitrate as PbNO3 twice. On heating it, what will happen? What will happen? Lead oxide will be formed, plus some gas is released. What gas is released? Nitrogen dioxide and oxygen gas is released. Lead nitrate on decomposition gives lead oxide plus nitrogen dioxide plus oxygen. Now this nitrogen dioxide gas is released in the form of brown fumes, brown colored gas. Okay, so if you have, what are the keywords for this particular reaction? You will have that a compound is taken and it is heated. Okay, on heating you will see that brown color gas is released or brown fumes are released. Then you have to understand that it is this particular reaction. This is the keyword here. Brown fumes are evolved. What are these brown fumes? These brown fumes are of that of nitrogen dioxide. What type of reaction is this? This question is also asked. So this is a thermal decomposition reaction. Also, what type of other reaction you can tell? This is also an endothermic reaction. Fine. This is all that you have to remember about this lead nitrate heating. Next, thirteenth reaction, which is a part of activity number 7, that is the electrolysis of water, where water is electrolyzed So you have that figure, right, in your textbook activity number 7. Next to that you have a figure where you have, a plastic mug, and then you have the 2 test tubes, graphite rods, hydrogen, oxygen, and you're passing a 6-volt current, right? All of this entire setup you have. That figure is also important. Okay, please note down the figure also, like as in note down means you have to remember what figure is there. You can slightly draw a small figure next to this particular reaction and keep, so that you remember that this particular image refers to this diagram. Lot of time the picture based question, where a picture is given, you get this picture either in MCQs or application based question, and this setup will be given. So you should quickly be able to identify that this is the electrolysis of water. Okay, so here what happens is water is decomposed in the presence of electricity, okay, to hydrogen and oxygen. Both hydrogen and oxygen gases are released. Okay, now if I quickly balance this, you will see that this is 2H2 and 2H2O. This will be the balanced reaction. Why did I balance? Because generally there is a question that one of the gas is produced in double amount of the other. Identify which gas is in double amount or which gas is in half amount. If you see the balanced reaction, you can see that hydrogen is 2, right? 2 hydrogen gas is produced and oxygen is only 1. So the gas which is produced in double amount is hydrogen gas. Okay, and sometimes in the figure also, in one electrode they will show more amount of gas, and in another one they will show less amount of gas. You have to identify which is what. So which is double in amount, you can identify it as hydrogen. Which is less in amount, you will identify that it is oxygen. Okay, so electrolysis of water, the reaction is very simple. Nothing is there. Water gets decomposed into hydrogen and oxygen. Okay, but what type of reaction is this? This is a decomposition reaction. But what type of decomposition? Electrolytic decomposition. Why? Because you are passing electricity. There you are giving heat, so thermal decomposition. Here what you are doing? You are passing electricity. So it is electrolytic decomposition. Fine. Electrolytic decomposition. Again, what type of reaction? Endothermic in nature. So this is an endothermic reaction. I hope this is clear now. Also, in this apparatus, one more point you can remember. In this apparatus, what we will do is, what water we will be taking for electrolysis, we will acidify it. So a question may be asked that why is it acidified? Why can't you directly perform the electrolysis of water? The reason is that to make this, when you acidify the water, right, it makes the water a good conductor of electricity. Because of the presence of water, because of the presence of acid, water becomes a good conductor of electricity. That is why we acidify it, okay, to make water good conductor of electricity. So this also you can put as a keyword and keep it over there. That is a probable question that you may get. Next reaction, again very important from the perspective of competency based questions. Okay, that is where you take silver chloride, decomposition of your silver chloride. Okay, decomposition of silver chloride and silver bromide. Where are these reactions used? You should be knowing. These are the keywords again. Black and white photography. Black and white photography. This reaction is used. So this will be mentioned. This keyword will be mentioned. Also that it may be mentioned that there is a compound which when kept in sunlight for some time, it will be mentioned that it is kept in sunlight. So again, sunlight is a keyword. Okay, it will form a silverish compound, a compound which is silver in color or gray in color. This will be mentioned. The color will be mentioned. Okay, so what are the things they can be telling you as keywords? That in sunlight it decomposes. Okay, and it forms a silver compound or a gray color compound, and they may or may not mention that it is used in black and white photography. If they mention it, good, very easy to understand. If they don't mention it, they may ask a question like, where is this reaction used? So you have to mention that it is used in black and white photography. So what happens is AgCl, right? AgCl will be white in color. Initially it is white in color. Okay, now when you keep it in sunlight, what happens is it decomposes. It splits into what? Ag plus chlorine will be released. Now chlorine is gas. I have already told, whenever we say chlorine, we'll write it in the gaseous form, Cl2. Okay, so AgCl, which is white in color, gets decomposed into silver and chlorine. This silver is actually the one which is in silver color, or you can tell it is gray in color. This gray color, because it is grayish in color, it is used in black and white photography. Okay, same reaction could be for AgBr, right? In the presence of sunlight, it will split into Ag plus Br2. So what type of reaction is this? This is a decomposition reaction. But why is this decomposition happening? Because of what? Because of sunlight, light, right? Light means photons. Photo. The word photo means light. That is why we say photosynthesis. Why photosynthesis? Photosynthesis happens because of sunlight, right? Presence of light. So same way, photolytic. Lysis means breaking. Electrolytic. Previously we said it is electrolytic. Now here photolytic decomposition. Why? Because this is occurring in the presence of light. And what type of reaction? Other type of reaction, it is an endothermic reaction. So these are the keywords, and these are the reactions that you should be remembering. Very simple, very easy to remember. By now we have completed 14 reactions, and I hope that you would have found them extremely very easy. Okay, next to this reaction in your NCERT, okay, there is a small box present next to which one, next to this one, this particular reaction, AgBr1. Down, carry out the following activity. They have specified it, okay, and they have told that you have to take barium hydroxide in a test tube, and to that you have to add ammonium chloride and see what will happen, whether it's an exothermic reaction or an endothermic reaction. Now you don't have to by heart this and keep. Why am I working this out? Just to make sure that you know this reaction at least once, how to write it. Okay, so it's a very simple reaction. They may give it in words, and you may be asked to write it as the equation form. Okay, so what it is? Barium hydroxide. So cross and write barium hydroxide, okay, plus ammonium chloride. Again you can cross and write ammonium chloride. What does it give? So you can see that there are ions here and here, so it will obviously be the double displacement reaction. So barium will take chloride and NH4 will take OH, and this will become barium chloride plus ammonium hydroxide. Okay, but remember, this is an endothermic reaction. If you perform this experiment and touch the test tube, right, you will feel it cooler. The test tube feels cooler because this is an endothermic reaction which will absorb the heat. Okay, and then the reaction will take place. Barium chloride and ammonium hydroxide. Okay, the precipitate here is the barium chloride. I hope this is clear now. You don't have to by heart this reaction. Okay, if they give it in the statement form, you should be able to write it, okay, by crossing it. But once, so that you know it, I have solved it out for you. Proceeding forward, the 16th equation is regarding the displacement reaction, activity 9 of your lesson. Okay, so here what do we have? We have a copper sulfate solution, right, which is blue in color. Copper sulfate solution which is blue in color, and we dip an iron nail into it. An iron nail is dipped inside this particular solution, and after some times what is noticed? It is noticed that the blue color fades. The blue color fades, and on the iron nail a brown color coating is deposited. On iron nail. So these are the keywords of this particular reaction. Using these keywords, you can easily remember them. What are the keywords? Blue color solution and iron nail. After some time, the blue color fading away and brown color of coating coming on the iron nail, plus the color will slightly change to pale green. Okay, so this word pale green, this is an indication of this particular reaction. So a simple displacement reaction, what happens? You take an iron nail and you are dipping it in a copper sulfate solution. So now iron is more reactive than copper. You should know the reactivity series by heart, which is coming again in your 3rd chapter. The entire reactivity series is given to you. If you notice that in that particular series, iron is placed above the copper. That means that iron is more reactive than copper. So iron can easily replace copper in the reactions. So that is exactly what happens over here. The iron is going to replace this copper, and what will be formed? Iron sulfate, right? iron sulfate will be formed and copper metal will be released, copper will be released. This copper goes and gets deposited on the iron nail. That is why the iron nail develops a brown color coating, a reddish brown coating on that. Fine. The brownish deposit on iron nail that appears is because of this copper which is displaced. Okay, and this iron sulfate is pale green in color. That is why the solution becomes pale green. Initially it was blue because of copper sulfate, but later when iron displaced copper from copper sulfate and formed ferrous sulfate, that time it became a pale green colored solution. So these are the keywords: blue iron nail, blue color fading away, pale green color being developed, and brown color deposit on the Fe nail. Okay. Simple reaction, displacement reaction. Again, now what is this type of reaction? This type of reaction is a single displacement reaction. This is a single displacement reaction that you should be remembering. Next, what do we have? The next displacement reaction, zinc reacting with copper sulfate. Zinc and copper sulfate, if you take, what will happen? Zinc is more reactive than copper. Just like iron, zinc is also more reactive than copper. So zinc is going to replace copper from copper sulfate solution, and this will form zinc sulfate plus copper. This is also a simple single displacement reaction which is there in your syllabus. Fine. One more reaction is there. The 18th reaction. What does it state? That if you take lead and copper chloride, lead and copper chloride, since lead is more reactive than copper, lead is going to replace copper in this chloride solution and it will form lead chloride. Lead chloride is PbCl2 plus copper metal will be released. Okay, the copper atom will be released. Now again, this is a single displacement reaction which is present in your syllabus. Fine. Is that clear? Now if we take any element, any metal which is less reactive than copper, for example, if you take gold, okay, gold is less reactive than copper. So what will happen if Au plus CuSO4 is there? This reaction will not take place itself. Silver cannot replace, or gold cannot replace copper from copper sulfate solution. So these type of questions also may arise where they give you the question, what happens that when you add zinc granules to a copper sulfate solution, okay, or when an iron and nail is dipped in a copper sulfate solution, what are the observations that you will do, what type of reaction this is, right, the balanced chemical reaction for this, and what happens if the iron nail is replaced by a silver nail or a gold nail, and why? Give the reason. So you have to tell that this reaction is not going to take place because gold is placed below the copper in the reactivity series. So it is less reactive, therefore it does not displace copper from the copper sulfate solution. Fine. I hope that is clear now. Let us proceed forward. Next, what do we have? Next we have the 19th reaction, the double displacement reaction, and which is nothing but your activity number 10 also. One example under double displacement, you have it. Okay, let us quickly see that. What is it? Sodium sulfate plus barium chloride. You have to remember this. This is sodium sulfate. Cross and write if you don't know. Sodium sulfate's formula. Okay, sodium sulfate plus barium chloride will give you what? Now the ions will get exchanged. Na is going to react with chlorine and Ba is going to react with sulfate and form NaCl plus barium sulfate. Now here NaCl is soluble in water. Okay, so this is colorless. Barium sulfate is a precipitate and this is white in color. This is white in color. White color precipitate is obtained. Okay. Na2SO4, BaCl2, it forms NaCl and BaSO4. BaSO4 is a precipitate which is white in color. So what type of reaction this is? This is a double displacement reaction, or you can tell that this is a precipitation reaction also. Both of them are correct. Fine. Let us now quickly proceed forward to the next one, the 20th one. Now we have the oxidation and reduction reactions. Okay, so oxidation reaction, in this we have heating up of copper. Heating of copper. Okay, which is the reaction of heating of copper? What happens when you heat copper or when you burn copper in air? Obviously what will happen? Copper will burn in the presence of oxygen. To form what? To copper, if I am adding oxygen, what I should get? Copper oxide. Okay, so cupric oxide, cross and find out the compound formula. It will be CuO. So copper reacts with oxygen to form cupric oxide. Now this is an oxidation reaction because to this element oxygen is being added. So copper is being oxidized to cupric oxide. Okay, now here which element is getting oxidized? Copper is being oxidized. Okay, remember the difference between oxidized, which element or which compound is getting oxidized. Okay, and there is a difference between the oxidizing agent. They are opposite things. The one to which oxygen is being added, that particular element is the one which is undergoing oxidation or which is being oxidized. Now here if you see, to copper we are adding oxygen, right? Oxygen is getting added to copper, so copper is being oxidized. Now because of what this copper is getting this oxygen? What is the other thing apart from copper over here? Oxygen, right? So here this oxygen is now the oxidizing agent. This is the difference between being oxidized and oxidizing agent. Many a times in the question it will be identify the oxidizing agent and reducing agent. What students will do is they'll write that this particular element is being oxidized, this is being reduced, and they'll lose marks over that. You have to be careful and understand what is being asked in the question. If still you have a doubt, then the thing is, you do one thing, you write which is getting oxidized, which is getting reduced. Okay, and next to it only you write the agent. You have written here like copper is being oxidized. Next to it only you write oxidizing agent is the other one, oxygen. Okay, similarly if you have something which is getting reduced, write this is getting reduced and this is the reducing agent. Fine. So now this particular example is an example of oxidation reaction. This is an example of oxidation reaction. This is also an example of combination reaction. So what happens is when you heat copper powder. So copper powder, you have seen copper, right? Copper is generally in which color? Copper is brown in color. Okay, so you will have in your question words like this: a powder which is brown in color, powder of an substance which is brown in color is heated. Okay, and then it is observed that it develops a black color on it. Okay, the surface becomes coated with black color. A black coating is formed. Identify the metal X and the substance formed because of which the black coating is coming. Okay, so this is an indication, a powder or a metal which is brown in color. Anything it can be. Okay, copper powder, or if they mention copper metal, whatever. So you have to remember brown color means it will be copper only. Okay, and when you are heating it, if it is developing a black coating, that means it is this particular reaction only, and these are the keywords for this reaction. Brown color powder, brown metal on heating will give you black coating. Fine, this is the reaction. Now there is a second part to this reaction which is mentioned in your textbook, is that if this particular compound that you have formed, copper oxide, if you take with the black coating and you pass hydrogen gas over it and heat it, then you are going to get back copper plus water. Understood? When I add hydrogen to copper oxide, this hydrogen will remove this oxygen and form water, and copper will get separated again. Okay, so if hydrogen gas is passed over this heated material, the black coating on the surface will turn brown again. So here black coating turns brown again. Okay, so this is the keyword for this particular reaction, and the gas that you pass is hydrogen. Okay, so now here what type of reaction is taking place? This is a reduction reaction. Why? Reduction reaction is the one in which you remove the oxygen or you add an hydrogen. So here with the help of hydrogen you are removing the oxygen present in copper. That is why this is a reduction reaction. Now here which is getting reduced? What is the substance? What is the compound that is getting reduced? Copper oxide is getting reduced, and that is why hydrogen is the reducing agent. Hydrogen is the reducing agent. Understood? So this is what you have to remember about this particular reaction. Okay, now the first one was the oxidation reaction. Now this is the second one is the reduction reaction. Fine. And what we can do is here, if you notice, actually this particular reaction, reduction as in copper oxide is getting reduced, but if you notice H2, if I talk about this particular H2, okay, if you notice this particular H2 and oxygen is getting added to it, right? So here H2, the hydrogen gas is getting oxidized to water, and copper oxide will be the oxidizing agent. Okay, so this you can tell this is a reduction reaction, or you can even tell that this is a redox reaction, because both reduction and oxidation are taking place here simultaneously. Copper oxide is getting reduced to copper, whereas hydrogen gas is getting oxidized to water. Okay, copper oxide is getting reduced to copper and hydrogen gas is getting oxidized to water. That is why this is an example of a redox reaction. Now a few more other redox reactions are given for you, that also please keep a note of them. Okay, let's quickly see them. 21st reaction, which is there in your syllabus, it is regarding zinc oxide. To zinc oxide, if I add carbon, okay, what will happen? It will get reduced. Now zinc oxide plus carbon, this is a reduction reaction. Now this has an oxygen, because of carbon it will get reduced to zinc, and carbon will get oxidized because of this oxidizing agent and become carbon monoxide. Fine, this is the next equation that you have. 22nd equation that you have, manganese oxide, it reacts with HCl acid. Okay, manganese oxide reacting with HCl will form what? It forms manganese chloride. Obviously this manganese and this chlorine will form manganese chloride, plus water plus chlorine gas is being released. So this is also a redox reaction. This is also a redox reaction, the 21st reaction, and this is also a redox reaction. Why? Here ZNO is getting reduced to zinc and carbon is getting oxidized to carbon monoxide. If you notice MnO2, manganese oxide, it is getting reduced over here. Why? Because the oxygen is being reduced, whereas if you notice HCl, to this H oxygen is being added, so this is getting oxidized here. Okay, and similarly here the chlorine, in this particular chlorine the hydrogen is removed, so removal of hydrogen is also oxidation. You know that oxidation means addition of oxygen or removal of hydrogen. Here in this particular thing, water, oxygen has been added, that is why this is also getting oxidized, and here in chlorine hydrogen has been removed, that is why hydrogen is getting chlorine is getting oxidized. So MnO2 is being reduced, HCl is being oxidized. MnO2 is the reducing agent, oxidizing agent, and HCl is the reducing agent. I hope this is clear now and all of these reactions have become easier for you. So now my dear students, we have reached the end of the very first chapter. After this you have the topics of rusting, corrosion, rancidity, all theory related topics. The reactions part has been completed. 22 reactions in the very first chapter that you should be remembering. A lot of them are important, and I have specifically pointed out which reactions are important. Reactions like this, like zinc oxide and carbon, or this manganese one, is not that important, but it's not like you cannot skip it, since it's a part of your textbook and questions can be asked from anywhere. Okay, but from this you do not get a lot of competency based questions like X, Y, Z, those type of questions you do not get. Wherever you can have those X, Y, Z components where you have to identify what is X, what is Y, what is Z, and you have to write the type of reactions, I have indicated it to you. Okay, so you have to be thorough with all the 22 reactions. And regarding the competency based questions also, I have pointed it out. I have told you what are the keywords and how you can use those keywords to identify what type of reaction it is. Okay, so what I want you to do now is pause the video. Very soon we are going to begin with the chapter 2 also, acid, bases and salts. Okay, before that I want you to pause the video right now here and see your notes, what you have prepared. I am hoping and I'm quite confident that you would have your books with you and you were noting it down along with me as the video proceeded. Okay, so now pause the video, just go through the reactions once, twice, thrice. Any reaction you're feeling still like, okay, I'm not thorough with this or I do not know about this, what you do is you write the reactions at least 5 to 10 times. Write it down, write it once today, write it 5 to 10 times again the next day and third day. So at least 3 days continuously when you write, what happens is 5 to 10 times when you write for the next 3 days, that reaction will enter into your mind. Okay, and if you are thorough with all the reactions, then what you do is just note down the headings, and once again before you proceed forward to the next chapter, make sure that this chapter is complete, the revision is complete, only then proceed forward. Just take the headings, the titles of the reactions and write the reactions on your own. Later balance them and check whether you have been able to write all the chemical reactions properly. And I assure you, if you do this, if you follow what I have told you, you will definitely be confident that you have remembered all the 22 important reactions of this particular chapter, all the 22 reactions given in your syllabus before you go to the next chapter. Once you are done with that, proceed to the next part of this video, which is nothing but the chapter 2, acid, bases and salts. Proceeding forward, students, now we will be beginning with the second chapter, acid, bases and salts. So brace yourselves. Remember, this is an easier chapter compared to the previous one, as in here you do not have a lot of chemical reactions to remember. A few reactions and your revision for this chapter will be done. Let us quickly dive into it. The very first reaction that we have in this particular chapter is that of zinc granules reacting with sulfuric acid. Activity number 3. What do we do here? We take about around 5 ml of sulfuric acid in a test tube, and then we add zinc granules to it, right? And a very similar type of activity we have already seen in the previous chapter. I think it was the second or the third activity that you had performed over there, or what was included in your syllabus. You have already seen the reaction and the chemical entire equation we have seen over there. Just now we are going through the apparatus over here in little bit detail. Okay, so you have a complete detailed apparatus present in your textbook under the activity stated. Okay, let us quickly see what is that. Okay, so what does the activity state? It says that you have to take 5 ml of sulfuric acid and add a few zinc granules to it, and then we will see that on the surface of the zinc granules we see small bubbles being formed, and this gas, what is being evolved, is then passed through a delivery tube, a long tube, into a soap solution, and from the soap solution the gas that will bubble out from the soap solution, we are going to bring a burning candle near it to see how it reacts, and we observe that it burns with a popping sound. Now the question is, what is happening and what is the reaction that is taking place? We have to explain everything in detail. So very simple, what we have is nothing but zinc reacting with H2SO4 sulfuric acid to form what? We know that zinc is more reactive than hydrogen. Okay, so it is going to replace the hydrogen and it is going to form zinc sulfate plus hydrogen gas will be released, right? This is the reaction, you have seen it previously. So zinc is more reactive than the hydrogen ion over here, in hydrochloric acid we have H2SO4, right? So hydrogen ion, it is less reactive, zinc is more reactive. So this zinc is going to replace the hydrogen over here and form zinc sulfate, and hydrogen gas would be released. Alright, so this is an example of a displacement reaction also. Why? Because zinc is a more reactive metal. Correct? Zinc is a more reactive metal than hydrogen. So what it does is, it will replace hydrogen and form zinc sulfate, and hydrogen gases evolved. Now, what were the phenomena that occurred when we performed the reaction? We noticed that on the surface of the zinc granules, small bubbles are being formed. Okay, what are these bubbles? These bubbles are present because of the evolution of hydrogen gas. Okay, so this indicates the presence of hydrogen gas. Now what we are doing, we are taking this hydrogen gas, passing it through the delivery tube into a soap solution. Now there's a question asked generally, why is it passed through a soap solution? Why not just burn it directly? Okay, from the test tube what hydrogen gas is evolved, why not test it directly, or why not pass it through plain water or distilled water? Why only soap solution? Okay, the question is, why only soap solution? So the answer is that it is passed through soap solution because these hydrogen bubbles, right, the gas when it passes through soap solution, it forms a very visible hydrogen bubble. And you can easily test it by bringing a burning candle near it. We have already seen that hydrogen burns with a popping sound, right? I had cleared this in the previous chapter, right? So hydrogen will burn with a popping sound. This is possible to test. You can test the presence of hydrogen only when the bubble is there, right? And you go and burn the bubble and see it burns with the popping sound. And the formation of the bubble is possible because of the soap solution. If it is plain water or something, hydrogen will get dissolved in it, okay, and you will not be able to test it. That is why in this particular activity what we do is we take a soap solution. Okay, and then when we bring the candle near the bubble will burst with a popping sound, and this indicates the presence of hydrogen gas. Okay, so now remember, this is an example for a general reaction. What is the general reaction? The general reaction is important, okay? You should remember the general reaction. It helps you write the chemical equations, the chemical reactions on your own. So what does the general reaction state? It states that acid plus any metal, if you react, an acid and a metal, if you react, they will always form a salt, okay, and hydrogen gas will be released. So this is the general reaction. You should be knowing this general reaction at the tip of your tongue. When you study this particular topic, the only key point that you should be remembering over here is that when an acid reacts with metal, it is going to form a salt and hydrogen gas will be evolved. Now given any acid and given any metal, you should be able to write the reaction on your own, and you should be able to balance it also on your own. For example, here one example is already there, zinc plus sulfuric acid. Let us take magnesium plus HCl, right? Magnesium is a metal, HCl is an acid. I told you, remember the three commonly used strong acids, right? HCl, H2SO4, which is nothing but sulfuric acid, and HNO3, which is nothing but your nitric acid, right? Apart from this, some bases you have to remember: NaOH, MgOH twice, KOH, calcium hydroxide, right? This is what I had asked you to remember. I hope you remember these. Okay, now using these, what we will be doing is that we will write a few reactions just so that you get an idea of how to write, chemical equations on your own for this particular topic. So let us say magnesium is reacting with HCl. What is it going to form? It is going to form a salt, right? Magnesium will react with this chlorine and form the salt. For the salt, what you will do? Magnesium chloride, you are going to cross it. Magnesium 2 plus chlorine minus 1, cross it and write it. So the salt formed will be magnesium chloride and hydrogen gas will be released. As simple as that.
Okay, let us take about iron. Iron, how does it react with sulfuric acid? Let's change the acid. Any metal plus any acid should give us the salt. So iron plus this sulfate will form ferrous sulfate, plus hydrogen gas will be released. Okay, one more metal, say zinc. How does it react with HCl? Okay, so zinc reacts with HCl to form zinc chloride, plus hydrogen gas will be released. As simple as that. Okay, aluminium plus H2SO4. How does it react? It will form aluminium sulfate. Aluminium sulfate is Al2SO4 thrice. You can cross it and check. Okay, and hydrogen gas will be released. See, just by remembering the simple straightforward general reaction, you can write any chemical reaction relating to this particular topic on your own. And this is exactly how you should be studying chemistry, not just by hearting and mugging up the reactions. You have to understand the reactions and be able to put forward the reactions on your own based on your understanding. Okay, so that's it for this particular first topic, where acids react with metal to form a salt and hydrogen gas will be liberated. Next, you have the same activity. In activity 2.4, you are performing the same experiment, except that this time instead of taking an acid, you take a base. For example, you take sodium hydroxide. So you take zinc granules and you add sodium hydroxide and see what kind of reaction it will produce. Okay, so you will have to warm up the contents of the test tube where you have taken zinc and sodium hydroxide, right? So you will have to warm it little bit to see the reaction. Okay, so what happens is that you will observe that hydrogen gas is released again and a product is formed. What is the product being formed? It is actually NaO and zinc reacting, and it will form sodium zincate, Na2ZnO2, and hydrogen gas will be liberated. Here also hydrogen gas is liberated, but the product formed over here is a zincate. The product formed over here is a zincate. Since it is reacting with sodium hydroxide, so the product formed over here is a sodium zincate. Since we have taken here zinc, it is zincate. Okay, if it is some other metal, it would be a different name. But you don't have it in much detail. If they will ask you, then it will be only this particular reaction that they are going to ask. Okay, you won't have any other metals coming up over here. Okay, it's always this particular reaction, so you have to remember it. Zinc plus sodium hydroxide gives sodium zincate. Sodium zincate. Now remember, this is something you cannot just obtain by crossing it. Okay, because you have sodium also, you have zinc also, and then you have oxygen too. So that is why you cannot obtain it by simple crossing. You will have to remember the formula of sodium zincate, but hydrogen gas is evolved here. Now one more point to remember is that, is this a general reaction too? In the previous activity, we told that the general reaction is any acid will react with any metal to form displacement reaction, right? Now here what is happening? Here also when a metal is reacting with a base like NaOH, it will form a compound. Okay, it will form a product and hydrogen gas will be released. But you have to remember that this is not a general reaction. This is not a general property of your metals or your bases, but here you should remember that this reaction is not possible with all the metals, only certain metals. Okay, you don't have to bother much about which metals and what are the reactions, what are the cases, what are the conditions, nothing to worry about. Just remember this particular reaction and that would be sufficient. Now let us proceed forward to the third one, and a very important one. You get a lot of questions in your exam from this particular part. Okay, that is the reaction of your metal carbonate or metal hydrogen carbonate with an acid. So let me just quickly write the general formula first here. Metal carbonate or metal hydrogen carbonate. Metal carbonate or metal hydrogen carbonate will react with an acid to form what? It will react with an acid to form salt plus carbon dioxide plus water. Okay, the carbon dioxide will be in the gaseous state and it will be released as the gas. This is the general reaction. Again, now how previously I told that if you remember the general reaction, you'll be able to write all the equations on your own. Same is the case over here. You have to remember the general reaction. That's it. That any metal carbonate you take or any metal hydrogen carbonate you take and react with an acid, it is going to form a salt, carbon dioxide and water always. Okay, and the carbon dioxide gas will be released. Now remember, how do you write the formula of metal carbonate or hydrogen carbonate? You should be able to cross it. Carbonate is CO3 2 minus, hydrogen carbonate or bicarbonate is HCO3 minus 1. Okay, so that's the difference. In your textbook there is only one example and you have an activity for it also, where you take sodium carbonate in a test tube and in another one you take sodium hydrogen carbonate and you add HCl to both of them and see what type of reaction is happening. Okay, and then whatever gas is evolved, you pass it through lime solution. So what have you taken in your textbook? Sodium carbonate and sodium hydrogen carbonate. Sodium carbonate formula is Na2CO3, cross it. Okay, and hydrogen carbonate is NaHCO3. Now you have to see how do they react with the acid. What is the acid taken in your experiment? It is HCl, right? So now what did we tell? We told that it is going to form salt plus carbon dioxide plus water. What will be the salt that is formed here? Sodium and chlorine. This will combine, right? So it will form NaCl plus carbon dioxide plus water. Here also again sodium with chlorine will form sodium chloride plus carbon dioxide plus water. As simple as that. Okay, any metal carbonate, here you have taken sodium carbonate, or you can take sodium hydrogen carbonate also. You react with HCl and it forms a salt which is nothing but sodium chloride. Carbon dioxide is released as in the gaseous form and water is also formed as a product. So this is the simple general reaction of any metal carbonate that you take. Now what happens when you perform this experiment? When you see this experiment, when you perform this experiment, it is noticed that when this reaction is completed, a brisk effervescence is produced. Brisk effervescence is produced means a very, have you seen soda bottles? Okay, or a 7-Up bottle, Pepsi bottle, you see that effervescence coming, right? If you shake it up a little bit, if it's very like in a calm state, okay, and if you just shake up the bottle little, you're going to see a brisk effervescence, the bubbling up, speeding up, the sodas getting bubbled up, right? So that is called as brisk effervescence. So when you perform this particular experiment in the laboratories, you will notice that a brisk effervescence is produced. Okay, so this is the keyword over here, brisk effervescence being produced. So this indicates the formation of your carbon dioxide. Anywhere you see in your question paper brisk effervescence, please understand that carbon dioxide is being evolved. Now how do you test the presence of carbon dioxide? Okay, now you saw the brisk effervescence and you said, ma'am had told us whenever there is a brisk effervescence, it's mostly a carbon dioxide gas. Okay, now how do you test it in the laboratory? If you perform this experiment, how do you confirm that ma'am was right? How do we check whether it is a carbon dioxide gas? Very simple. All you have to do is, you have to take lime water, which is nothing but calcium hydroxide. This reaction again you have studied in your previous chapter when you were studying about slaked lime producing quick lime, and then lime water or the slaked lime. When you whitewash the walls, it reacts with the carbon dioxide in the atmosphere to form calcium carbonate and water, right? This is what you have already studied. Same reaction over here. Here we are calling it as slaked lime, or you can call it as lime water also. Okay, so this lime water, whatever this carbon dioxide is produced over here, you pass it through a lime water solution. Why? What will happen? What happens when you whitewash the walls? When you whitewash it, then a layer of a white paint
is observed on the walls, right? A whitish residue is on the walls, a shiny gloss is obtained. So same thing will happen here when you pass the carbon dioxide produced over here into the lime water. It will form calcium carbonate and water. Okay, this calcium carbonate will make the lime water milky in color. Again, this is the keyword for this particular reaction. Lime water turning milky. Lime water is, you can think it's colorless. Okay, now when you pass carbon dioxide into it, what happens is it turns milky in color. It's like something like if you take milk and add a little bit of water to it, or if you take water and add a few drops of milk to it, you get a milky color solution, right? Something like this we observe here also. So you get a milky solution which indicates the presence of carbon dioxide. One more way you can test whether it is carbon dioxide only is that you keep on passing the carbon dioxide gas into it. As in, whatever carbon dioxide is produced, after it turns milky also, continue passing this carbon dioxide gas into the solution for some more time. Okay, don't just stop this reaction, continue it. After some time you will notice that the solution becomes colorless. Why? What happens is when you pass excess of carbon dioxide into lime water, it becomes colorless. The reason is that the calcium carbonate that was formed and water that was formed, that reacts with more carbon dioxide to form calcium hydrogen carbonate. Calcium hydrogen carbonate, and this is soluble in water. That is why what happens is the milkiness goes away. Milkiness vanishes. Okay, when does this happen? When you pass carbon dioxide in excess. Now all these words that I have written, these are your keywords that will come in the question. The main keywords are brisk effervescence, lime water turning milky, and in excess the milkiness vanishes. These three are the main keywords using which you will be identifying this particular reaction. I hope that is clear now. Okay, so the actual reaction what you are studying right now is that metal carbonate and metal hydrogen carbonate, take any metal, they will react with an acid to form salt plus carbon dioxide plus water. What is the guarantee that the gas being produced is carbon dioxide only? How are we to just simply trust the words someone has told us? For that, what we do is we do a test, a two-step test. Just like in WhatsApp you have your two-step verification, right? Authentication, where you are therefore checking the safety of the conversation. Correct? It is for the privacy of your conversation. Similarly, for this particular reaction to test carbon dioxide, you have a two-step test, lime water test, where you take lime water is nothing but calcium hydroxide. It will react with the carbon dioxide that you pass through it and form calcium carbonate, which turns the solution milky. But if you pass carbon dioxide in excess, in more amount, what happens is the milkiness vanishes, because this calcium carbonate will react with carbon dioxide and water which is already present in the solution to form calcium hydrogen carbonate, which is soluble in water, and it loses its white color. Let us proceed forward now to the next reaction. The next reaction is the neutralization reaction. I think you all will be knowing this. This is something which you learn from a very young age, from your younger classes also. And it's a very simple reaction, neutralization reaction. What does the neutralization reaction say? It says that any acid plus any base, if you take, they will always form salt plus water. So this is the general reaction. Take any acid, take any base, you are going to get salt plus water. For example, take an example of an acid HCl, a base NaOH. What it will be doing is it will be forming a salt, right? So Na and Cl will combine and form NaCl, and this hydrogen and OH that you have here will combine and form water. Same with H2SO4, you see H2SO4 plus NaOH, what will happen? It's going to form sodium sulfate, which is nothing but Na2SO4, and water will be released, right? So this is your simple neutralization reaction. Acid and a base reacts to form salt and water. Okay, let us proceed now. Next, what do you have? Next we have the reaction of metal oxide with acids. Okay, a metals oxide with acid. Again, if you remember the general reaction, it will be easy for you to write the reactions on your own with an example, or for the metal oxide that has been asked in your question paper. Okay, so metal oxide plus acid, what does it give? Now let me explain it in a simpler way over here so that you remember well. Metals are generally, you can think, like basic in nature. Okay, and your non-metals, you can take them as acidic in nature. See now, here you see NaOH, KOH, magnesium hydroxide, calcium hydroxide, all of them are bases, right? And what are they made up of? They are made up of metals reacting with OH, correct? So basically metals are generally basic in nature. Non-metals are acidic in nature. For example, HCl, H2SO4, HNO3, all of them, you see hydrogen is a non-metal, right? So it forms acids. Okay, so in general you can remember metal means basic, non-metal means acidic. Okay, so now this reaction is very simple to remember. Metal oxide, what is metal? Basic in nature. So this whole thing is basic in nature. Okay, so this is something similar to a base plus acid. What will it form? A base and acid forms salt plus water, a simple neutralization reaction. So that's it. Even though it's a metal oxide, because it is basic in nature because of the metal, what it does is it will behave like a simple neutralization reaction and form salted water. Okay, so let us take an example for this and understand. If you take copper oxide, for this is given in your activity number 7, I guess, copper oxide, and add HCl to it, what will happen? Copper oxide and HCl, what will happen? It will form salt plus water. So it will form cupric chloride plus water. Okay, and here the solution will become blue green in color, and your copper oxide will get dissolved. Okay, why is this blue green color coming? It is coming because of the formation of this cupric chloride. Okay, that is why the solution turns blue green in color. So nothing but simple neutralization type of reaction. Fine, let us proceed forward now. Okay, next you have the topic of how do acids and bases react in water solution. What happens when you add acid into water or base in water? What will be the reaction? Okay, so simple reaction or general reaction you can remember. For example, let us take the example of HCl. Okay, what happens when you add it into water? Remember, acids in water will split. Split as in they will dissociate into their ions. They will split into the ions. What is HCl made up of? It is made up of H plus and Cl minus, right? Only when you cross them you get HCl. So what this water will do is it is going to split this HCl into H plus and Cl minus. So this HCl will no longer be HCl. It will get split. It will get dissociated into H plus and Cl minus. Then what happens is this H plus will react with this water and form H plus will react with water and form H3O plus. This is called as the hydronium ion. This is called as your hydronium ion. This is called as hydrogen ion. This is called as hydronium ion. The amount of hydrogen ions or the amount of hydronium ions will determine the strength of your acid. More the quantity, more the concentration of H plus ions or hydronium ions, more stronger is the acid. Lesser the quantity, lesser is the strength of the acid. So very simple, any acid that you take in water will dissociate, split into the ions, then the hydrogen ions will combine with water to form the hydronium ion. So these are generally what happens is these are combined together and written like this: HCl plus water together, combined reaction only we write, it forms H3O plus Cl minus. Okay, both of these reactions combined will give you this reaction. Okay, if you write this and this also is okay, and if you write it in one reaction also, it's fine. Okay, now what happens when you add base to a water? For example, you take any OH and you add water to it. Okay, so what will happen? It will get dissociated into the ions, which is nothing but Na plus and OH minus. One more example, you can take KOH, it will dissociate it in water to K plus and OH minus. Okay, one more example, magnesium hydroxide will dissociate in water to form magnesium is 2 plus, correct, plus OH minus. So this is what happens when you take a base and add water to it. Okay, when you take a base and when you dissolve it in water, you will notice that it gets dissociated into ions, and bases will produce OH minus ions. The more the concentration of OH minus ions, the stronger the base is. Okay, now bases, not all bases are soluble in water. Okay, they don't dissolve in water. The bases which dissolve in water, like the bases here, right, they will dissolve in water. So these bases are called as alkalis. These bases are called as alkalis, and remember, alkalis will dissociate in water to give you hydroxyl ions, or these are called as hydroxide ions. Okay, not hydroxyl, hydroxide ions. Got it? Simple. So what basically happens in your neutralization is that every acid has a hydrogen in it, right, and some other part. For example, in HCl you have H and Cl, H2SO4 you have H and sulfate. So you will have hydrogen plus some other ion in the acid, right, and in the base what you will have the metal plus the hydroxide, metal plus the hydroxide, correct. So this will be your base. So this will form salt. How? This portion and this portion will combine and form the salt, and this portion and this portion will combine and form water. Okay, salt plus water. So this is the concept of your neutralization reaction. I hope that is clear now. Proceeding forward, we come to the 7th equation of your syllabus. Very simple, very easy ones. Actually, after this we have all the preparation type of reactions, and they are quite simple actually, right? So the first one is the chlor-alkali process. Again, very important. After this, all the reactions that I am going to write are important only. You will be getting one out of these in your question paper for sure. Okay, so the first is the chlor-alkali process. What happens in the chlor-alkali process? What do? We take an aqueous solution of sodium hydroxide, or what we call as the brine solution. Okay, what do? We take brine solution. What is brine solution? Brine solution is nothing but salt water. If I tell in simple word, layman language, it is nothing but salt water. What is salt water? It is nothing but, what is salt? Sodium chloride. Your normal common salt is sodium chloride. If I add water to it, it becomes brine. Okay, so brine solution, NaCl plus water. This is what you are taking, and what you are going to do, you are going to pass electricity to it. What are we going to do? We are going to pass electricity to it. When you pass electricity to it, it will decompose. It will decompose and form NaOH plus chlorine gas plus hydrogen gas. Got it? So brine solution, when you pass electricity to it, it forms sodium hydroxide and chlorine gas and hydrogen gas. Now because this is an electrolysis sort of process, so we have a cathode, we have an anode, right? Anode is the one which is connected to the positive of the battery. Cathode is the one which is connected to the negative of the battery. Remember, chlorine gas will be given out at the anode and the hydrogen gas will be given out at the cathode. Fine. And sodium hydroxide will be released separately. At the anode, the chlorine gas will be released. At the at the cathode, the hydrogen gas will be released. Now this chlorine gas may be used for different purposes, maybe a water treatment and treatment of or the disinfection of your swimming pools, CFCs, pesticides, etc. And the hydrogen gas may be used for fuels, for fertilizers, for ammonia, etc. And your NaOH produced will be used for soaps, detergents, paper making, artificial fibers, degreasing metals, etc. Got it? So it is a very simple process and an easy process. The diagram of this is important. Please do practice out the diagram too. Proceeding forward, the next what we have is the bleaching powder reaction. Bleaching powder. Okay. Now remember that we said that this chlorine is produced at the anode, right? The chlorine produced here can be used for making the bleach. You know what bleaching powder is, right? Which is used in your cleaning process and all. Okay. So how is this bleach formed? With the help of chlorine. So what happens is we take a dry slaked lime. What is slaked lime? By now you should remember slaked lime is calcium hydroxide. We take dry slaked lime and we react it with chlorine. Okay, so this forms the bleach. Calcium oxychloride, which is nothing but this product, plus calcium chloride plus water. Okay, so what is the bleaching powder reaction? Where you take dry slaked lime, react it with chlorine to form calcium oxychloride plus calcium chloride plus water. Okay, so this reaction you should be remembering. Simple. They may ask you about how bleaching powder is prepared and everything, so you will have to write this reaction and explain it to them. Okay, so now how do you remember this reaction? Sometimes it's very easy to forget this. How do we remember this? What is the trick here? The trick over here is that what you can do is you can replace this hydrogen by one chlorine over here. You have two chlorines, right? So one chlorine you replace by hydrogen over here, and one more chlorine you attack it to this calcium. Okay, so you get two calcium products, right? So first one is calcium oxychloride. Okay, then calcium chloride plus water will be released. Remember, this is your bleach. Okay, and it is white in color. It has a strong smell of chlorine in it, and this is also called as calcium hypochlorite. Fine, you can call it calcium oxychloride, or you can also call this calcium hypochlorite. Got it? So this is the bleaching powder reaction. Proceeding forward, the next one you have is the baking soda reaction, right? Let me change the color of the pen. Okay, yeah, baking soda reaction. Okay, so do not get confused with the baking powder, bleaching powder. Be clear, because bleach has a strong smell of chlorine, so it will be formed from chlorine. That is how you can remember. Baking soda, it's used in your kitchen for baking cakes, or it may be used for the preparation of idlis, etc., etc., right? So it's used in your kitchen, so you can remember that it is formed from a very common thing found in your kitchen, which is nothing but NaCl. Okay, so that is how you can remember. If you're forgetting, it will be formed from NaCl by reacting with water, carbon dioxide and ammonia gas. So four things are there. First thing, baking soda used in kitchen, so we have NaCl. Next, water, carbon dioxide, ammonia. Water, carbon dioxide, ammonia. Water, carbon dioxide, ammonia. Water, carbon dioxide, ammonia. Okay, I hope you all remember it now. Sodium chloride plus water plus carbon dioxide plus ammonia. Now first write the formula of bleach. What is bleach? What is baking soda? It is NaHCO3, right? Sodium hydrogen carbonate. Okay, so sodium hydrogen carbonate. Now what is remaining? Ammonia and chlorine is remaining, right? So the remaining product will be ammonium chloride. As simple as that. Fine. You should be remembering what is baking soda. It is sodium hydrogen carbonate. Okay, that way also you can remember that we have salt plus water plus carbon dioxide and ammonia. Okay, now how to write the product? Sodium hydrogen carbonate. Sodium hydrogen carbonate. Done. After that, what is remaining? NH3 and Cl. So ammonium chloride will be the other product. Fine. Now what happens when you heat sodium hydrogen carbonate? Basically when you're cooking and all or when you're baking, this sodium hydrogen carbonate will get heated up, right? You're going to heat it. So what will happen? It will decompose, right? So it will decompose and form sodium carbonate plus water plus carbon dioxide. Gases will be released, water and carbon dioxide. Okay, remember this is an example of thermal decomposition reaction because one product is decomposing into two or more products, right? So this is the example of thermal decomposition. Fine, I hope it is clear now. Sodium hydrogen carbonate on heating will split into sodium carbonate, water and carbon dioxide will be released. Now one of the important uses of baking soda is that it is used in the preparation of baking powder. Okay, so most of the bakers who are just beginners, they're always confused between baking soda and baking powder, and it makes a huge difference in the dishes that they are baking, be it cakes or anything else. Okay, because the function of these two compounds are different. Baking soda is used for a different purpose, baking powder is used for a different purpose. Now what is the difference? Baking soda is sodium hydrogen carbonate, NaHCO3, and what is baking powder? Baking powder is sodium hydrogen carbonate, which is nothing but your baking soda plus you add some small acid to it which you can eat, basically edible acid, for example tartaric acid. Okay, generally tartaric acid is added to this. So together when both of these are mixed, it is your baking powder. So that's the difference between baking soda and baking powder. Baking soda is simple sodium hydrogen carbonate, baking powder is sodium hydrogen carbonate plus some acid like mild tartaric acid you will put into it. Okay, so what happens when you take this baking powder and add water to it? Okay, so what happens? See, what is baking powder? Baking powder is nothing but sodium hydrogen carbonate plus some mild acid, right? That acid full thing I'm not writing, I'm just saying that it has some H plus ions in it, that is why it is an acid, right? So here we are making things simple. This is your baking soda plus this is your acid part where you are only showing the reaction with the hydrogen ions of it. You have the other portion of it also. Okay, the other ion is also there, but right now we are only considering the H plus ion. What will happen? It will form carbon dioxide plus water plus some sodium salt of acid will be formed, right? This sodium plus the other portion of this acid together will combine and form the sodium salt of acid. Okay, so baking soda plus acid, in that we have only taken the hydrogen ion, and when we see the reaction, we see that carbon dioxide and water is being produced. Now this carbon dioxide is very important. Why? It's used in recipes of cakes, etc., so that it will cause the rising of your cake and make them soft and spongy. Okay, So it's used in cakes for making the cakes soft and spongy. Fine. Next, which is the next reaction? The next reaction is of washing soda. Baking soda, baking powder. Now we have washing soda. What is washing soda? Washing soda is nothing but it is a chemical which you obtain from sodium chloride. Washing soda's formula is nothing but sodium carbonate, and you have 10 molecules of water of crystallization in it, right? So washing soda is formed by taking sodium carbonate Na2CO3, okay, and if you add 10 molecules of water to it, it forms washing soda. Okay, so it forms a compound like this, Na2CO3, which has 10 molecules of water attached to it. This dot indicates that 10 molecules of water are attached to it, and these water molecules are called water of crystallization. Okay, so this is your washing soda. Washing soda is nothing but where you are taking sodium carbonate, and when you add 10 molecules of water to it, you get washing soda. Okay, that's it about washing soda. Next, we are seeing plaster of Paris, the very last reaction of your chapter, and then you will be done with this portion also. Plaster of Paris. Plaster of Paris, you must have heard about plaster of Paris, right? It's used by doctors. Whenever you have a fracture or something, they use the POP, and it provides support to the fractured bones in the right positions, right? So that it can grow properly. Now, how is this plaster of Paris made? Plaster of Paris is made from a compound called as gypsum. Okay, what is gypsum? Gypsum is nothing but calcium sulfate, which has 2 molecules of water of crystallization. Okay, so what is POP made up of? It is made up of gypsum, which is nothing but calcium sulfate, which has 2 molecules of water of crystallization. Now what happens when you heat this gypsum? Okay, when you heat this gypsum at 373 Kelvin, which is basically 100 degrees Celsius, at such a high temperature, when you heat this, it loses its water. Because it has water, when you heat it, it's going to lose its water. So what happens is, it will lose its water and form calcium sulfate. And how much water it will lose? It will lose 1.5 molecules of water and form calcium sulfate. How many molecules of water will be there now? Total there were 2. You are losing 1.5 molecule of water. So half molecule of water will be remaining, right? So it will form a compound of calcium sulfate which has only half molecule of water of crystallization. This particular product is nothing but your plaster of Paris. Got it? So how do you make POP? You have gypsum. Okay, when you heat gypsum at 373 Kelvin, it loses its water, molecules of water of crystallization. How many molecules it loses? 1.5 molecules it will lose and form calcium hemihydrate. How many molecules you have here? Half molecule, right? So calcium hemihydrate. Okay, this calcium hemihydrate is nothing but your plaster of Paris. Now what is gypsum actually? Gypsum is nothing but it is a hard substance. Gypsum is a hard substance. Okay, it's like rock hard, extremely hard. You must have seen POP bandages, right, for the fractured bones. So how are they? They're very hard, right? So what happens is, actually gypsum, what doctors have is the POP powder. This one, calcium hemihydrate, that is there. They have it in the white color powder form. White color powder form. This is nothing but your plaster of Paris. To that, what the doctors do is they add water in certain concentration. Basically what they're doing is they're adding 1.5 molecules of water to this plaster of Paris. Okay, so what will happen? Isn't it going to get converted back to gypsum? Well, because what is plaster of Paris? It is calcium sulfate having half molecules of water. To that you are adding 1.5 molecule of water, so it will be 1.5 plus half, total 2. So it's going to form calcium sulfate with 2 molecules of water, which is nothing but gypsum. Correct? So as we already know, gypsum is the hard substance. So doctors initially have POP in the form of powder. They mix it with water, and when the fractured bones are supported, it forms a hard mass, which is nothing but your gypsum. Okay, so here now again the keywords. This is important from your concept base of point of view, because a lot of questions are asked. A white color powder on adding water forms a rock hard or a hard mass substance. Identify A, B, C, etc., etc. Okay, these type of questions. So these are the keywords you should be remembering. POP is white colored powder. When you add water to it, it forms a hard substance. That hard substance on heating at 373 Kelvin forms back the plaster of Paris. Okay, something like that type of questions you may be getting. So okay, so you have to remember these keywords. So students, here now we reach the end of the second chapter. I hope you are all very excited and happy that you have quickly completed the revisions of your 2 chapters. Okay, a little longer than necessary, but it is important from exam point of view. So I am pausing at every point and explaining the keywords, the key points that you should be mentioning or you should be knowing, that will help you remember the reactions also, and it will help you in identifying the reactions also. Fine. So then now we will be beginning with the next chapter, which is nothing but your metals and non-metals, and we will be seeing all the reactions in detail here too. So now students, we will be beginning with chapter number 3, metals and non-metals. The very first equation that you have is under activity 3.8, the 8th activity, where you are asked to take a magnesium ribbon and some sulfur powder and burn it in air, and whatever ashes you get, that is basically the oxides that you'll be getting, you'll have to dissolve them in water and see. So what is the reaction that is taking place here? They have told that you have to take a magnesium ribbon and sulfur powder. Okay, so the first equation is magnesium ribbon. When you burn it, you already know this reaction. This is the very first reaction in your syllabus that we have seen. Magnesium ribbon burns in air with a dazzling white flame to produce magnesium oxide, right? So magnesium plus oxygen gives you magnesium oxide. This is one reaction, and the same thing if I do with sulfur, what will happen? Sulfur will burn in oxygen to form sulfur dioxide, right? Now this is the product that will be formed, sulfur dioxide. Next, they have told that whatever products you get, that is magnesium oxide and sulfur dioxide, we are supposed to dissolve it in water and check the acidity or the basicity. Now magnesium oxide is in solid state, that is it is in the ash form. This, when you dissolve in water, what will happen? I'm going to write the reaction here only. This is the second step from, okay, let me write it down itself or else it might be a confusion. So this is the first part. The second part is magnesium oxide. When you dissolve in water, what will happen? It will form magnesium hydroxide. Okay, whenever you add water to any oxide, it is going to form an hydroxide. Okay, so magnesium oxide will react with water to form magnesium hydroxide. Now this you already know, this is basic in nature, correct? We have already studied this previously. So this is basic in nature. Now what about sulfur dioxide? Sulfur dioxide is evolved in the form of fumes, that is in the gaseous state. Now this, if you react with water, what happens is it will form sulfuric acid. Okay, it's going to form sulfuric acid, which is acidic in nature. It is acidic in nature. One more thing students, just note over here that this is not sulfuric acid, it will be sulfurous acid. Sulfurous acid, okay. So this is not the reaction for your sulfuric acid, this will be sulfurous acid, which is again an acid. So it will be acidic in nature only. The difference between sulfuric acid and sulfurous acid is, there's a small difference, okay. Sulfuric acid is H2SO4 and sulfurous acid is H2SO3. 3. So this is the reaction that will be taking place. Let us now proceed forward. Okay, the next reactions what you have, the second set of reactions are how do metals combine with oxygen. You know very well, any metal, if you combine it with oxygen, it is going to form metal oxide, right? For example, if you take copper plus oxygen, what will happen? When you burn it with oxygen, it will form copper oxide, which is black in color. We have already seen this in the very first chapter. Copper powder you take, and when you burn it in oxygen, it will form it will develop a black coating on it, and that black coating indicates the formation of copper oxide. So very simple, any metal plus an oxygen, when you react it with that or when you burn it in oxygen, it will form an oxide layer. Okay, next one more example let us take, which is there in your textbook. Aluminium plus oxygen will form aluminium oxide. Okay, so this will be Al2O3. If you are not able to write the chemical formula, as I told you, cross it and write, you will be able to get the compound easily. So aluminium reacts with oxygen to form aluminium oxide. So this is the general reaction and few examples of that. The general reaction is metal plus oxygen will give you metal oxide. Okay, so this you remember. Again, this is a type of combination reaction, and if you are burning it in air, so then it is a type of combustion reaction also, right? So it will be exothermic in nature. Next, one more important point, as I told in the previous chapter, I think you remember it. Let us just quickly revise it over here. Metal oxides are basic in nature, right? This is what you know. Metals are generally basic in nature, and metal oxides are also basic in nature. What do you mean by basic in nature? They show the properties of a base. They behave like a base. So if I add an acid to a metal oxide, what should happen? Just imagine that this metal oxide is a base itself. Okay, so if I add an acid to a base, what will happen? A simple neutralization reaction will take place, right? So that is exactly what will happen. If you take a metal oxide and add an acid to it, then salt will be formed, okay, and a neutralization reaction will take place. That is basically salt and water will be produced. If you take any metal oxide, for example, I will take magnesium oxide, okay, it will react with HCl to form what? Salt. So magnesium chloride plus water. So this is a general reaction. Okay, so any metal oxide, since it is basic in nature, it will react with an acid to form salt and water, which is nothing but the neutralization reaction. But very important, put a star mark over here and write this point, that aluminium oxide is an amphoteric oxide. You get a lot of questions on amphoteric oxides every year. Okay, so what is an amphoteric oxide? An amphoteric oxide is the one which can act as a base also, which can act as an acid also. That is, it will show both the natures. What did I tell? Metal oxides generally are basic in nature. They behave like bases. But amphoteric oxides are those oxides which can act like a base also, which can act like an acid also. So they have a dual nature in that. Okay, they react with acids also, they react with bases also. Okay, so remember, aluminium oxide is an amphoteric oxide. Similarly, zinc oxide is also amphoteric in nature. So these two examples you remember, zinc oxide and aluminium oxide are amphoteric in nature. So what will happen if I take aluminium oxide and react it with HCl? HCl is what? HCl is an acid, right? So in this situation, aluminium oxide will behave like a base. So now what will it form? It will form salt plus water, correct? So what is the salt that will be formed? Aluminium chloride, AlCl3 plus water will be formed, correct? And what if I take aluminium oxide and a base like NaOH, for example? What will happen? So now this is the base, so aluminium oxide will act as a acid, right? So what should be formed? Salt should be formed. The salt will be sodium aluminate. The salt will be sodium aluminate. You will have to remember this formula. Sodium aluminate and water will be formed. This is the salt that is formed. Similar to that reaction, sodium zincate we had, right? So this is sodium aluminate. Remember this particular reaction. Fine. So these are amphoteric oxides. Exception, that is why it is an important topic to be remembered. Next, you should remember that most of the metal oxides are insoluble in water. Okay. Most metal oxides are insoluble in water, but a few of them will be soluble in water, and those will form alkalis, similar to what we have seen in the previous chapter. For example, if I take sodium oxide, okay, and if I dissolve it in water, it gets dissolved and forms a base, sodium hydroxide. Similarly, potassium oxide, if I take K2O and if I react it with water, it will form potassium hydroxide. Okay, so these bases which dissolve in water, okay, these are your alkalis. Fine. So only those metal oxides which can form alkalis will get dissolved in water. Not every metal oxide gets dissolved in water. I hope that is clear now. This is regarding your metal oxides. How do metals burn in the presence of oxygen? How do they form the oxides? What happens when the oxides are dissolved in water? What happens when the oxides are reacted with acid, bases? All those topics are done. Next, we are proceeding forward to see how do metals react with water. Okay, how do these metals react with water? That is what we will be seeing now. So remember, again we have a general reaction for this. What is the general reaction? See, metals, they react with water to form metal oxide and hydrogen gas will be released. Metal plus water will give us metal oxide plus hydrogen gas will be evolved. This is one general equation you should be remembering. And also metal oxide will react with water to form metal hydroxide. An example of this we have already seen, magnesium oxide reacting with water to form magnesium hydroxide. Just now we saw NK. Okay, so these are the general two reactions. Based on this you can write any reaction. Fine. Metal plus water gives what? Metal oxide plus hydrogen gas is evolved. Metal oxide plus water will give you metal hydroxide. This is a general reaction, but remember, not all metals react with water. Okay, and not all metals react with water at the same temperature. Some react with water when it is at lower temperatures, that is when it is cold. Some react when the water is hot, or some react when the water is in the gaseous form, that is they react with steam. Unless it is in the steam form, the reaction will not take place. Okay, this is a general reaction. Metals, they will react with water in whatever form it is, and whenever they react with water, they will form a metal oxide and hydrogen gas will be released. This is the general equation, yes. But when does this reaction happen? That conditions will vary. Okay, whether the water is cold, warm, or in the vapor state, etc., etc. These conditions will determine how the reaction takes place. Okay, now remember, metals like potassium and sodium, they will react violently with cold water. They will react violently with cold water. And what will be the chemical reaction that will take place? Obviously, it is this general reaction only. So, for example, potassium will react with cold water to form potassium oxide plus hydrogen gas will be released. Same with sodium. So, the reaction is easy to remember. Only thing is you have to know this condition. Okay. So, metals like sodium and potassium, they react violently with cold water, and this reaction is highly exothermic. Extremely exothermic. The minute you perform this experiment, it will catch fire. What will catch fire? The hydrogen gas that is being evolved, right? Because of the exothermic nature, it will catch fire instantly. This potassium oxide will again react with water to form potassium hydroxide, right? K2O will react with water to form potassium hydroxide. We know that. So what we do is generally we combine these two reactions and write. How do we combine and write? I will say that potassium plus water forms, because this is very quick reaction, that is why directly I am going to write potassium hydroxide only over here. So potassium hydroxide will be formed and hydrogen gas will be released. Okay, so this is actually a combination of both these reactions. Okay, the K2O will instantly form potassium hydroxide. Fine, got it? Same thing with Na. Na will react with water to first form sodium oxide. That will again react with water to form sodium hydroxide and hydrogen gas will be released. Okay, now since this is highly exothermic reaction, you can write heat is evolved here just to indicate that this is an exothermic reaction. Fine. Next what metal do you have? The next metal that we have is calcium. Okay, now remember the reaction of calcium with water is less violent. That is, in this case also what will happen is hydrogen gas is evolved, but it is not so violent and there's not a lot of energy being released. Energy is released, heat is released, but the heat that is being evolved is not sufficient for the hydrogen to catch fire. So this is an exothermic reaction. It will release hydrogen gas, but it won't catch fire. Okay, so calcium plus water, it will form calcium oxide and then it forms calcium hydroxide, right? So calcium hydroxide plus hydrogen gas will be released. As simple as that. But remember, now what happens, because the hydrogen gas is not catching fire, this hydrogen gas is there, right? So because of this hydrogen gas, the calcium starts floating. The calcium metal will start floating because of the bubbles of hydrogen gas formed, and they will stick to the surface of the calcium metal. Stick to surface. Okay, so the hydrogen gas bubbles will stick to the surface, and because of this the calcium metal will start floating. Next up comes magnesium. Remember, magnesium does not react with cold water, it reacts with hot water only. What type of water? Hot water. To form what? It will form what? It will form magnesium hydroxide and hydrogen gas will be released. Okay, magnesium hydroxide and hydrogen gas will be released. Magnesium reacts with hot water. Next, metals like aluminium, iron, zinc, they do not react with cold water also. They do not react with hot water also. But they react with steam to form metal oxide and your hydrogen. Okay, so you have which one? Aluminium, iron and zinc. Okay, this will react with steam only. So aluminium will react with steam. This water is in the steam form and it will form aluminium oxide and hydrogen gas will be released. Okay, iron will react with steam to form iron oxide. So this is Fe3O4 and hydrogen gas will be released. Zinc will react with water to form zinc oxide, water as in steam, to form zinc oxide and hydrogen gas will be released. So in short, you have to remember sodium, potassium react with cold water, violently catch fire. Okay, next you have calcium. It reacts with water and it is an exothermic reaction, but the heat is not sufficient for the hydrogen to catch fire. So catching of fire here, it will not take place. Magnesium does not react with cold water at all. It reacts with hot water. What happens when it reacts with hot water? It forms magnesium hydroxide and hydrogen gas will be released. Remaining three metals, aluminium, zinc and iron, they react only with steam and form the oxides and hydrogen gas will be released. Metals like other metals you have copper, lead, silver, gold, they do not react with water at all. Which one? Copper, gold, silver, okay, lead, these do not react with water at all, neither in the cold form, neither in the warm form, nor in the steam form. So now students, the next set of equations that you have is regarding activity number 11, where you take metal samples and you react them with HCl, dilute HCl, and see how they react. Okay, and then later about nitric acid also it is mentioned. The equations are not given in the textbook, but I'll be writing them down over here because it is a part of your activity. Fine. So remember, sodium and potassium, they react very violently with dilute HCl and they form the chlorides along with the evolution of hydrogen gas. So basically what is happening, it is a metal reacting with an acid, and you know the general reaction. Any metal will react with an acid to form salt plus hydrogen gas will be evolved. So the same thing is happening over here. If you take sodium or if you take potassium also, they will react with HCl and they'll form the salt, that is sodium chloride, and hydrogen gas will be released. Here potassium will react with HCl to form KCl and hydrogen gas will be released, and this reaction will happen very vigorously, extremely quick. Okay, next what metal you have? Calcium. Same order what you studied previously: sodium, potassium, calcium, magnesium, aluminium, zinc, iron. That order only you can remember. Okay, so now sodium, potassium done. Calcium, how does it react with HCl? Same way, it is going to form calcium chloride and hydrogen gas will be released, but this is also vigorous. Okay, this is also vigorous, but not as vigorous as potassium or sodium. Okay, vigorous only, little lesser in quantity. Next, what we have? Magnesium. Magnesium will react with HCl to form what? Same thing, magnesium chloride plus hydrogen gas. Again, this is also vigorous, but not as vigorous as calcium. Okay, vigorous but not as much as calcium. Fine. But what happens is all of these reactions will happen rapidly, quickly. Next we are going to see aluminium. Okay, what happens with aluminium? Aluminium also will react with HCl to form aluminium chloride and hydrogen gas will be released. Same thing will happen with zinc and iron also. But remember, aluminium reacts with dilute HCl slowly in the beginning. In the beginning, it is slow. Why? Because in the beginning what happens is aluminium is already covered with a layer of aluminium oxide in beginning. There is a cover of aluminium oxide in the beginning. So because of that, the reaction is very slow. But as the oxide layer gets dissolved in the acid, the reaction becomes fast, and as soon as the acid attacks the surface of aluminium, actual surface of aluminium, not the aluminum oxide, the reaction starts happening very rapidly. Okay, so remember here the initial reaction is slow. Why? Because aluminium has a protective layer of aluminium oxide on it. There is a layer of aluminium oxide on it. So when you dissolve it in acid, what happens is it is slow because the oxide has to get dissolved. Once the oxide is dissolved, this particular reaction only will take place, and it will take place vigorously. Fine. Next we have zinc. Again, same thing, zinc will react with HCl to form what? It is going to form zinc chloride and hydrogen gas will be released. That is the reaction. But zinc also reacts slowly with HCl, not as vigorous or as fast as these metals that we have. Similarly, iron also reacts with HCl, but it reacts extremely slowly to give you ferrous chloride and hydrogen gas. Okay, so if you have iron and if it reacts with HCl, it is going to form ferrous chloride, not ferric chloride. Okay, ferrous chloride and hydrogen gas will be evolved, but this is very, very, very slow. Nevertheless, the reaction will still take place. Apart from this, the metals that you have like copper and gold, silver, lead, what we saw previously, these do not react with dilute HCl or sulfuric acid. Okay, any acid if you take, they do not react with them. Which one? Copper, mercury, silver as in Ag, Au, all these do not react with any acid too. Fine, I hope this is clear now. Next, it is also mentioned about nitric acid. Okay, it's mentioned theoretically that nitric acid will react with HCl. Okay, so if you have iron and if it reacts with HCl, it is going to form these reactions of salts being formed and hydrogen gas being released, this is possible with HCl, this is possible with H2SO4, but with nitric acid this is not possible, because nitric acid is a very strong oxidizing agent. So as soon as that hydrogen is formed, that nitric acid will oxidize that hydrogen into water, okay, and itself nitric acid is going to get reduced to some nitrogen gas, maybe nitrogen monoxide, nitrogen dioxide, dinitrogen oxide, anything like that, okay. So here that is not what is happening, but in nitric acid, remember, nitric acid is a strong oxidizing agent. This question may be asked in exam. Why do metals not form or not release hydrogen gas when they are being reacted with HNO3, that is nitric acid? So the reason is that nitric acid is a strong oxidizing agent, and it will convert the H2 that is being evolved into H2O, and itself gets reduced to what? It will get reduced to some oxide of nitrogens, and dinitrogen oxide, nitrogen monoxide, nitrogen dioxide, any one of them, depending upon the reaction. Okay, but remember, we have two exceptions for these, and these are important: magnesium and manganese. Okay, magnesium is this, it will react with very dilute nitric acid to form the salt, which is nothing but magnesium nitrate plus hydrogen gas will be released. Same with manganese. Manganese is another metal you should be remembering. Okay, it is again reacting with very dilute HNO3 to form manganese nitrate. Very similar, the formula is to magnesium nitrate. Manganese nitrate and hydrogen gas will be evolved. So these are the exceptional cases. Fine. Is that clear now? If you have any doubts, please do drop them in the comment section, and I will be happy to clear them for you. Next, activity number 12, and that particular topic is about displacement reactions, and we have seen in detail about the displacement reaction in the first chapter, so I'll not be repeating it over here again. Remember, here at this point you should be knowing the reactivity series very well. Okay, just like I told how you have to remember the ions by heart, and you should be knowing the first 20 elements by heart order wise. That is, you should know the atomic number of each one of them, the electronic configurations of each one of them. Similarly, the reactivity series is equally important. You need to be knowing the reactivity series by heart, and the order should be correct too. Okay, so potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. So this is the order from most reactive to the least reactive. Why do you need to remember the reactivity series? You need to remember the reactivity series because if you are given a reaction between a metal, okay, and the salt solution of another metal, for example, zinc and copper sulfate, iron and copper sulfate, okay, or silver and copper sulfate, you may be asked whether the reaction occurs or not. When you take the solution of, say, copper sulfate and dip an iron nail in it, will the reaction happen, and why, and what type of reaction it is? That time, how do you judge whether a single displacement reaction has taken place or not, or whether it will take place or not? So the simple thing is, you have to see the reactivity series. If the metal is more reactive than the metal which is present in the salt solution, okay, for example, copper sulfate here, so you have to check whether iron is more reactive than copper. If it is more reactive than copper, as in the reactivity series, if it is placed above copper, then yes, the reaction will take place. And you know that iron is placed well above the copper. Okay, so that is why it will displace copper from the copper sulfate solution and form iron sulfate, and copper will be released. But the same reaction if you try to carry out with silver, no reaction will take place. Why? Because silver is less reactive. Silver is placed below copper in the reactivity series. That is why no reaction will take place. So you may get questions on this, and you will be asked to justify your answer. That time you will have to provide justification in the same manner as how I just explained it to you now. Let us proceed forward now. Straight away now, the sixth set of reactions that you have is under the occurrence of metal. That is where you are learning about the extraction of different types of ores. Okay, so first we have the cinnabar. See, it is very important to remember the ore's name, which metal it belongs to, what is the chemical formula of that particular ore. So cinnabar is an ore of mercury, and the formula of cinnabar is HgS, that is mercuric sulfide. Fine. Now if you want to know the ion form of mercury, it is Hg2 plus. The charge on mercury is Hg2 plus. Fine. Now you know that cinnabar, which is an ore of mercury, it exists in the sulfide form. Okay, and now you have to get pure mercury out of it. How are you going to get the pure mercury out of it? Now remember, before we actually dive into the chemical reactions, just remember a small concept. If the ore is in the sulfide form, I'll write it over here so that you remember. Okay, if the ore is in sulfide form, what are we going to do? We are going to first convert the ore into oxide form by a process known as roasting. This is the general thing you have to remember. Any sulfide ore will be first converted into the oxide form by a process called as roasting. And what is roasting? Roasting is nothing but you are burning in excess oxygen. Burning in excess oxygen. And whenever I say we are roasting it or we are burning it in excess of oxygen, you should write plus O2 in your chemical reaction. Am I clear? Whenever I say burning in excess oxygen, you are to add oxygen as a reactant on the reactant side of your equation. Fine. So in simple words, sulfide will be first converted into oxides with the help of a process known as roasting, where you burn that particular sulfide in excess of oxygen. That is, you are going to provide extra oxygen and make sure that the sulfide is first converted into an oxide. And if it is a carbonate ore, then what you will do? You will convert it into the oxide form with the help of a procedure known as calcination. The carbonate ores will be converted into the oxide ores by the process of calcination. Okay. So what is this process of calcination? What happens in calcination? Okay. In calcination, you are going to heat this carbonate ores in limited oxygen. You are going to burn this carbonate ores in limited oxygen. Here it is excess oxygen, here it is limited oxygen. So in this you should not write O2 on the reactant sides. Okay, whenever there is excess only, then you will add plus O2. The sulfide ore plus O2 will form the oxide. Okay, but here directly you are going to show that it will be heated and the oxide ore will be formed. Once you get the oxide ore will be then simplified into your required metal. Okay, so that simplification may vary little bit. Coming back to cinnabar is HgS. Now what type of ore is this? This is a sulfide ore. So you will have to first convert it into oxide. Okay, now before I write the reaction, one more doubt which generally arises is, why do you have to convert this into oxides? Why not directly convert it into mercury? Why not directly convert it into carbonates? Okay, so remember, this is because it is easier to obtain the metal from oxides than obtain it directly from the sulfide ores or the carbonate ores. That process is very difficult, not feasible. Okay, so first we convert them into oxides, and from oxides it's very simple to just obtain your metals. Okay, this is the reason. Now what is cinnabar? Cinnabar is mercuric sulfide. So it is a sulfide ore of mercury. So how are you going to convert it into oxide? What did I tell? You will have to roast it, and in roasting what will happen? You roast it in excess of oxygen, right? So I will have to write plus O2 here. If this was a carbonate ore, I will not write plus O2 over here. Okay, so HgS plus O2 will give me what? Oxide has to be formed. So mercuric oxide plus what will happen? this sulfur has to be released. It will be released in the form of sulfur dioxide. The sulfur, when it reacts with oxygen, it is going to be released as sulfur dioxide. Then what happens? This mercuric oxide, to convert to mercury, what you have to do is you have to just heat it. Simple procedure. Just heat it. It will form Hg plus O2. This is the metal that you have extracted, and oxygen gas will be released. Fine. This is the process of extracting mercury from the ore of cinnabar. Now, apart from this, your copper. Next, it is mentioned about copper in your syllabus. So, copper is also present as sulfide in your nature. Okay. So, in nature, copper exists as cuprous sulfide. This is cuprous sulfide, Cu2S. So, cuprous sulfide, here carbon is in the state Cu plus. Okay. So, cuprous sulfide, what you have, you can directly burn it in oxygen. Okay. And when you heat it, what will happen is you will get cupric oxide, and SO2 will be released. Now, this cupric oxide that you get, this will again react with this cupric sulfide, and when you heat it, this is basically acting as a reducing agent here now. Okay. So, it will reduce it. So, first what happens is copper sulfide, you are adding oxygen to it, it forms cuprous oxide and sulfur dioxide. This cuprous oxide will again react with this only, which is a reducing agent. This will reduce the copper into copper, and again sulfur dioxide gas will be released. Okay. So, this is how the copper ore will be obtained, and here you just have to heat it. Nothing but you just have to heat it in air. Basically, oxygen will be added and the reaction will proceed as shown now. Fine. Simple, easy to remember. Okay. Let us proceed forward now. Let us see the reaction for zinc. Okay. So, zinc, what happens is zinc exists as zinc sulfide in the nature, and it also exists as zinc carbonate in nature. So, both the type of ores you will get. Suppose it is the zinc sulfide ore, then what we will have to do? We just saw that you will have to perform the process of roasting, which is nothing but you're going to burn this in the presence of excess of oxygen. That is why I have written plus O2 over here, and this will get converted to zinc oxide, and sulfur dioxide gas will be released. Why sulfur dioxide? Because sulfur is there over here. Okay. And if it is a zinc carbonate ore, what will happen? ZnCO3 plus O2. Do I write plus O2 over here? No. Why? Because carbonate ores will be reduced to zinc oxide just by simple process of calcination. That is, you are heating it in limited oxygen. You are not providing extra oxygen, so you will not write O2 over here. Just simply on heating this, it will form zinc oxide, and because there is carbonate over here, the carbonate, whenever you see a carbonate over here, a carbon dioxide will be released here. So, carbon dioxide gas will be released here. Now, you got zinc oxide. From sulfide ore also you got zinc oxide, and from the carbonate ore also you got the zinc oxide. Now, what do I have to do with the zinc oxide? This zinc oxide I have to reduce it. How can I reduce it? I can reduce it with a reducing agent, which is nothing but carbon, or it is also mentioned as coke here. Here we don't say carbon, we say coke. Coke will reduce this into zinc, plus what will be reduced? Carbon monoxide. So, carbon monoxide will be released. Here it is not carbon dioxide, it is monoxide. You have to remember this. Fine. So, carbon is used here as a reducing agent. Also, coke is a reducing agent. You can use coke, or you can use a metal which is more reactive than zinc. Why? What happens if I use a metal which is more reactive than zinc? A displacement reaction will take place, single displacement reaction will take place, and this metal will be released and an oxide of that particular metal will be formed. So, manganese, what you have, manganese dioxide, it is generally, you obtain manganese from it with the help of aluminium powder. What you do is manganese oxide, instead of adding coke, we add aluminium to it, aluminium powder to it. So, what will happen? Displacement reaction will take place. Because aluminium is more reactive than manganese, it is going to displace manganese and form aluminium oxide manganese will be released, and this is an highly exothermic reaction. So heat will be released. It is an exothermic reaction. Fine. Now remember that these are extremely highly exothermic in nature. They are so exothermic that the metal that you obtain will be in the molten state. The metals that you obtain will be in the molten state. Why molten state? Because of the heat they will melt. You will not get it in the solid form. The heat is so much that the metals will be present in the molten state. And there is a use of this particular thing. The exothermic reaction that is taking place over here, you use it in real life also, where this is used in the thermit reaction. Again, the thermit reaction is an important part of your syllabus, very important part, the thermit reaction. Okay, so in thermit reaction what happens is you take iron oxide that is ferric oxide, and you displace it with aluminium. When you displace it with aluminium, what will happen? Aluminium is more reactive than iron, so it will form aluminium oxide. Iron will be displaced and lots of amount of heat will be released. So what iron you get will be in the molten form, and this iron is used to join railway tracks or cracked machine parts. Okay, the molten iron is used to join the railway tracks. If there is a gap between them, to join them, we use this particular reaction. And the machine parts which have a crack in them, to fill those cracks, we use this particular reaction. And it's very helpful because iron is in the molten form. You can just fill those cracks, and when it cools down, it will get converted into the solid form and the crack will be filled. Okay, so this is the thermit reaction, a very important reaction from your board's perspective. So children, that's it from your chapter number 3. The chemical reactions of this chapter are completed. Apart from the chemical reactions, you have a lot of other topics also, like electrolytic refining, alloys. Okay, since they do not have a lot of chemical reactions in them, that is why I have not included in this video, but that does not mean that it is not important. Okay, it is quite important. The rusting part, the corrosion part, galvanization part, anodizing part. Okay, and the differences between your metals, non-metals, how ionic bonds are formed, the properties of ionic bonds, all of them are also very important, so you'll have to go through them. This video is in particular about your chemical reactions only. These reactions generally students find it difficult to remember. Okay, so it would be good if you have those reaction list with you. That is why this video is being made. I have not included those topics for this purpose, but that does not mean that you should skip them. Please do not skip them. Quickly go through them also. Okay, but because they are easier than these reactions, generally, you'll be able to do it very quickly. The revisions of those particular topics also will be done quickly. Fine. Next, we'll be proceeding to chapter number 4. In chapter number 4, you do not have a lot of equations. We have a very few chemical reactions. Okay, in chapter number 4, since it's the beginning of organic chemistry, you have to focus more on the formation of covalent bonds. How are covalent bonds formed, or what are the different compounds which form covalent bonds. You have certain structures in your textbook, right? And then you have alkanes, alkenes, alkynes, the functional groups, the IUPAC naming. All of these are an important part. Apart from that, you have very few chemical reactions at the end of the chapter. That is what we will be seeing next. Proceeding forward, chapter number 4 and the very last part of your chemistry, hydrocarbons or carbon and its compounds. Correct? Yes. So let us quickly dive to the very last part of the chapter. We are not going to discuss about how the covalent bond is formed, why carbon forms covalent bonds, the versatile nature of carbon, or the saturated, unsaturated hydrocarbons, the functional groups. We are not going to discuss all of them. Okay, I assume that you know those particular topics. Once you are thorough with those topics, then see this part of the video where you have to revise the chemical equations. Okay, so we will directly begin from the chemical reactions of your hydrocarbons, starting with the very first reaction, which is nothing but the combustion reaction. Now, what is the combustion reaction? The combustion reaction, in simple, if I tell you, any hydrocarbon that you see, okay, any hydrocarbon it can be, whether it belongs to alkanes, alkenes, alkynes, or it has a functional group, whatever. Any hydrocarbon that you have, it will burn in oxygen to produce carbon dioxide, and lots of heat will be produced. Any hydrocarbon, if you burn it in oxygen, if you perform the combustion reaction, carbon dioxide gas will be released and heat will be evolved. That means that is this reaction in particular is an highly exothermic reaction. Also, because hydrogen is there, so water also will be produced. Okay, because of the presence of hydrogen, water also will be produced. So if it is just carbon, if you burn it in oxygen, it will give you carbon dioxide and heat will be released. But if it is a hydrocarbon, that is if hydrogen is also present, then no matter what type of hydrocarbon it is, the products are always this: carbon dioxide gas being released, water being produced, and large amount of heat and light will be produced. Okay, you can mention light also over here. So if I tell you coal, you're burning coal. Coal is what? Coal or coke, it is carbon only, right? So it will be this reaction, carbon plus oxygen giving you carbon dioxide and heat and light, correct? And if I take a hydrocarbon, suppose if I take methane, CH4, and I burn with oxygen, what do I get? Because hydrogen is there, that's why carbon dioxide, water plus heat and light. In place of methane, if I take ethanol, okay, so it will be CH3, CH2, OH, ethanol, correct? This will react with oxygen. Does not matter how big the carbon chain is, or if we have an alcohol group over here, no. If it is a hydrocarbon, what will happen is, it will burn in oxygen to give you carbon dioxide, water and heat and light. So as simple as that. So that is the first reaction. Next we have the oxidation reaction. Oxidation reaction. Okay. What is the oxidation reaction? In oxidation reaction, what happens is, we will convert your alcohols to carboxylic acid. Okay. In oxidation reaction, we are converting alcohols to carboxylic acid in the presence of some oxidizing agent. Some oxidizing agent will be there. We will be converting alcohols to carboxylic acid. What is the functional group of alcohol? OH. What is the functional group of carboxylic acid? COOH. Right. Now this is an oxidation reaction, means oxygen should be added. Correct? You had one oxygen here. You have two oxygens over here. So oxygen is being added. So in the presence of some oxidizing agent, this alcohol group is oxidized to carboxylic acid. Okay, so let us take a simple example. In your syllabus, what do you have? Alcohol. Ethanol you have. What is the formula of ethanol? You should be knowing CH3, CH2, OH. If you don't know, also remember ethanol. Okay, CH3, CH2, OH, ethanol. In the presence of some oxidizing agent, it will form a carboxylic acid. What type of carboxylic acid it has to form? It will form vinegar, acetic acid, or ethanoic acid. Here it was ethanol. Here it should be ethanoic acid. And what is ethanoic acid? Ethanoic acid is nothing but CH3COOH. This is your ethanoic acid, or this is the vinegar that we consume in our daily lives. Okay. Now, what is the oxidizing agent? Does this reaction happen on its own? No, there has to be some oxidizing agent, here the oxidizing agent is alkaline KMNO4 or acidic potassium dichromate K2Cr2O7, and in both of these you will have to heat it also. Okay, simply adding it would not be sufficient. You will have to heat the contents of your test tube too. So ethanol in the presence of alkaline potassium permanganate, KMNO4 is potassium permanganate. Okay, in short you say KMNO4, and the down one is acidic potassium dichromate, okay, K2Cr2O7. You will have to remember this oxidizing agents. At this point here you will have to remember the oxidizing agents. You cannot just write them on your own. Next, what reaction we have? Next we have the addition reaction. What is the addition reaction? Addition reaction is very simple. In addition reaction, what you are doing is you are converting an unsaturated hydrocarbon. Unsaturated hydrocarbons are what hydrocarbons? They are the hydrocarbons with double bonds or triple bonds. Okay, you are converting them into saturated hydrocarbons. Okay, and what are these saturated hydrocarbons? Which have single bonds with them. So that is the simple addition reaction. This addition reaction also occurs in the presence of a catalyst. Okay, you are going to convert them. How are you going to convert them? In the presence of a catalyst, and you are going to add hydrogen to it, and this will convert your unsaturated hydrocarbon, which is nothing but your double bond or a triple bond, into saturated hydrocarbons, that is a single bond. For example, okay, if I have a carbon with a double bond here, let me take this unsaturated hydrocarbon, double bond one I am taking. It can have anything over here, not just hydrogens. It can be any functional group. It can be hydrogen also. R means R is any functional group. Okay, or it can be hydrogen also. Fine. Now what happens when you perform the addition reaction on this? For this reaction to perform, you will have to have a nickel catalyst, and you are going to add hydrogen. This hydrogen is very easy to remember. This nickel catalyst is there to speed up this reaction. Okay, this hydrogen is easy to remember because why? We need to put hydrogens over here. That is why. Okay, now what will happen is, in presence of this nickel catalyst, and when you add hydrogen, this double bond will break and get converted to a single bond. That means now carbon will be carbon. We will have one R here, one R here, one R here group, one group here. But now is carbon's valency satisfied? Carbon is supposed to form 4 bonds, right? Whether it is single bond, double bond, doesn't matter. It should have 4 bonds. Now here, how many bonds does this carbon have here? 1, 2, 3. Means it still needs one more bond, one more covalent bond. Where does this one more covalent bond come from? It comes from this hydrogen. This hydrogen is there, right? So now one of this hydrogen will go to this carbon, one of this hydrogen will go to this carbon. And here you will have one hydrogen, one hydrogen. Now what is this type of compound? This is a saturated hydrocarbon, an alkane, right? So this is your simple addition reaction. Got it? If the same thing, if I had to take for a triple bond, again it's very simple. Okay, so if this is a carbon-carbon triple bond, say I'm taking hydrogen only over here. Okay, now what I do is I'll add in nickel catalyst and hydrogen gas. This will get converted into alkanes, but not directly. What happens is, first this one will get converted to an alkene. How? One of these bonds will break here. Okay, and it will be carbon-carbon double bond, hydrogen. Now see, this carbon needs one more hydrogen, right? So there are 2 hydrogens over here. One hydrogen will go here, one hydrogen will go here, and it will form hydrogen bond here. Now see, and alkene is formed. From an alkyne, an alkene was formed. Again from this alkene, if I perform this experiment where I take nickel catalyst and add hydrogen, what will happen? I am going to get an alkane. Okay, so one more hydrogen will be added and an alkane will be formed. So this is your simple addition reaction. Is that clear? Very simple, quite simple equations you have. Almost like, common sense type of reactions you have. Next, what do we have? Next, we have the substitution reaction. Again, very simple, very easy. In substitution reaction, what happens is you will have a alkane basically. Okay, so you may have an alkane like methane. To this, you are adding a halogen. Halogen means chlorine, bromine, fluorine. As I told you in the first part of this video, where we were studying about what the ions, the charges, cations, anions. There I told that halogen family means chlorine, bromine, fluorine, iodine. Okay, so to an alkane or to an hydrocarbon, if I add chlorine or any halogen, what will happen? Very simple. Okay, what will happen is, just see the structure over here for methane. It is carbon and 4 hydrogens, correct? To this, if I add a chlorine, what happens is, simple thing, this chlorine will come, carbon is friends with this hydrogen. You have some people in your life, right, who cannot see you being happy or friends with someone. What they do? They come, they make sure that your bond with that particular person that you're having is broken. They sideline you and they become friends with that person. Alright, so same thing chlorine does over here. Very bad thing that chlorine is doing, but it does it. It's a way of life. Okay, so chlorine comes here, breaks the bond of hydrogen, kicks hydrogen away, and one of this chlorine will get attached to carbon here. Okay, so what happens is carbon, hydrogen, chlorine, hydrogen, hydrogen. Okay, so chloromethane will be formed here. Then next, what will be formed? Now hydrogen tells that, okay, because you broke my bond with my friend carbon, I'm going to go and become friends with your ex-friend, which is nothing but chlorine, right? The other chlorine. So they will form a bond and form HCl. Okay, so very simple thing is, one of the hydrogens will get replaced by one chlorine and CH3 will be formed, and that one hydrogen and one chlorine will form HCl. Now this may repeat. This will happen in the presence of sunlight. You should remember this, in the presence of UV radiation. Okay, or you can say sunlight, because sunlight is also UV only. If I keep continuing this reaction, then what will happen? CH3Cl. Okay, I forgot to write Cl over here. It is CH3Cl. CH3Cl, if I still add chlorine, what will happen? Again, one hydrogen will be replaced by chlorine. It will become CH2Cl2. Maybe this hydrogen is replaced by chlorine. Okay, and again HCl will be formed. Like this reaction will keep on happening till all the 4 hydrogens are replaced by chlorine and you get the compound CCl4. Okay, so at CCl4, this reaction will stop. But in your textbook, only one is mentioned. Nevertheless, I have explained the next steps of the substitution reaction also. Okay, all cool, all easy. Let us proceed forward now to the next reaction, which is nothing but regarding your preparations of ethanol. So in ethanol, you have only 2 reactions to remember. Okay, don't think that it is too much. Just see it that in ethanol, I just have 2 reactions to remember. And what is it? First is the reaction of ethanol with sodium and reaction of ethanol to give a unsaturated hydrocarbon, 2 of them. Okay, so first one is reaction of ethanol with sodium. Okay, now this is very simple, straightforward. What is ethanol? As I told you, you should be able to write the structure of ethanol, the formula of ethanol. If you are not able to write, if you don't remember, then by heart it. Okay, so it is CH3CH2OH. what happens when this ethanol reacts with sodium? Very simple. What will happen? Nothing will happen. Simple thing is this H group, the hydrogen group will be replaced by Na and the hydrogen gas will be released. So simple reaction, CH3, CH2, and this oxygen is there and Na will be joined here and hydrogen gas will be released. Now remember, here the bonds between all of them are covalent bonds. Okay, between oxygen, hydrogen, carbons, the bonds are covalent bonds. But the minute sodium comes, one of the bond becomes ionic bond. Okay, so then this oxygen with sodium, it will form an ionic bond. That is why a minus and plus is shown here to indicate that this is not a covalent bond, this is an ionic bond. That's it. Okay, the name of this compound is sodium ethoxide. Sodium ethoxide. Fine. Next reaction is ethanol giving unsaturated hydrocarbons. Means you should get a double bond here. Unsaturated hydrocarbons. So what you have to do is you take ethanol CH3, CH2, OH. Okay, I have to convert this into a unsaturated hydrocarbon. Okay, so let me just open up the structure of ethanol. Ethanol looks like this, CH3. Okay, you have H here, you have two hydrogens here, and you have OH here. Okay, now if I want to convert this into a double bond, what I should do? What should happen is, these carbons should form a double bond. Okay, now if I need to form a double bond over here, this carbon also should remove one bond and this carbon also should remove one bond, correct? Only then I can put a double bond over here, right? Because carbon maximum, it needs 4 bonds, right? Now it already has 4 bonds. So if both of these carbons need to form a double bond, then one bond of each should be removed. So what this carbon does is, it has only hydrogens, right? So it is going to remove one hydrogen. And this carbon has an option of OH also, it will remove this OH. Basically, if I remove these 2 bonds, I can form a compound like this, C double bond C, H, 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 H. Correct? This H I am writing over here. Simple. What did I do? I removed H and OH. H and OH means what? I removed the water. When I remove the water from ethanol, it forms an unsaturated hydrocarbon. Now, how do you remove water from something? Either you heat that something. Okay, here heating is not possible. Like, you will have to heat it, but simply heating is not enough. Okay. Other thing what you can do, you add something which has the ability of pulling out water. Okay, or we can say which can act like a dehydrating agent, whose job only is to pull water out and dehydrate something. So what is the dehydrating agent? A very good dehydrating agent is concentrated sulfuric acid. It has the ability to dehydrate anything and pull out water from it. So we take concentrated sulfuric acid, which is the dehydrating agent, and heat this particular reaction at 443 Kelvin to get ethene. And what will happen? The water, it has gotten dried up, right? It will be released as H2O. So this is the simple reaction of ethanol with unsaturated hydrocarbons. I have explained it via this particular way so that it is easier for you to remember. So nothing but from ethanol, when you're removing the water, when you're dehydrating it, it is going to form ethene. Simple, easy. Let us proceed forward now. So your reactions regarding ethanol are done. Next, what do we have? Next, we have reactions of your ethanoic acid, right? A very, very, very important reaction. Also remember, these two reactions are also quite important from both perspective. These are generally asked. Okay. Next, we have for your ethanoic acid, right? Again, ethanoic acid, we have the esterification reaction. Very, very important. Almost a sure question for your boards. Again, this can be asked from conceptual point of view also. X is reacted with Y or something like this. The same thing may happen over here also. They may put it in the form of X, Y's and do it. Okay, and an alcohol is converted to an carboxylic acid with the presence of an ingredient Y. Explain it. So you'll have to tell why is the concentrated H2SO4, which is the dehydrating agent. Why is it called as the dehydrating agent? Okay, all those points you have to mention. Fine. Now esterification also can come from conceptual point of view. So how is this esters formed? What are esters? Esters, esters are sweet smelling compounds. Sweet smelling or fruity smelling. You get the smell of fruits. So these are the keywords. If you see these words, sweet smelling, fruit, fine. If this is mentioned, then you have to understand that this is the esterification reaction. These are the keywords they will be mentioning. Sweet smelling and fruity smelling. Okay. So in esterification reaction, what will happen? You are going to take ethanoic acid and ethanol. The two compounds you are studying about in carbon and its compounds, specifically you are studying about ethanol and ethanoic acid, vinegar and ethanol. Combine both of them only. What is ethanol? CH3, CH2, OH. What is ethanoic acid? CH3, COOH. Easy to remember. Why? Because these are the only two compounds in specific you are studying in this particular chapter. Are you studying about other compounds? No, right? You're not studying about chloromethane. You're not studying about particular one alkene, methane, the properties of methane. No, just studying about ethanol and ethanoic acid. So we are combining both of them only. Boom, boom reaction. Okay. So this in the presence of an acid, that acid is nothing but a catalyst. Okay. What will happen is this reaction, we draw an arrow like this. This is to show that it's a reversible reaction. So you can do this side of the reaction and get this products, or this reaction can happen in the reverse form and you can get these products also. That is why these arrows. You will get an ester. Okay, and water will be released. Now, how do I show the formation of ester? This is generally one confusion. Very simple way to write the ester is this. Okay, from this side of the reaction, just take this much portion. We have to remove water. Again here in esterification reaction, what you have to do is you have to remove the water. So what I will do from here to here, I will take up this as one part. Here hydrogen will be removed. From here OH I will remove. Okay, and from here I will take this much portion. These two will combine and form water. Got it? From ethanol I am taking this much portion. What is this portion? CH3, CH2O. Correct? CH3, CH2O. From this portion I am taking CH3COO part. I am going to flip this. I am going to write it from this direction. From like this I am going to write it. From CO onwards. Okay. So what is that? You will have the CO bond and the CH3 bond. Ulta, right? CH3COO. This part. Okay. So this is nothing but your ester. If I open this up and write, it is nothing but CH3CH2O carbon, and this is the oxalic group, right? Sorry, carboxylic group, right? So it will be double bond O. Okay. And CH3. So this is your ester plus water will be released. Got it? First take ethanol, ethanoic acid, remove water. From here take out hydrogen, from here take out OH. Okay, and then join them, you will get the ester, which is nothing but the fruity sweet smelling substance. It is used in the making of what? It is used in the making of perfumes. It is used in the making of flavoring agents. These are also the keywords you should be remembering. Flavoring agents. Easy peasy. Simple. A lot of students tell that, ma'am, the esterification reaction is so difficult to remember. It's not difficult. You just have to understand it. Okay. You just know, you should know how to join them, like two blocks you join, right? Like Legos, if you take and if you join them, how do you join them? Same way. You just have to join the two parts. It's very simple. It just looks big, but in reality, it's quite simple. Next, what you have? Next, you have the ester. Now, what the ester, what we can do? It is a sweet smelling compound. Yes, you can use it in perfumes and everything. Remember, ester in specific is also used in your saponification reaction. Saponification means it is used in the preparation of soaps. And in soaps, what do we do? You should be knowing this. You learn it from your childhood that in soaps we add base. Which is the common base you use? Sodium hydroxide. So take a simple ester. Ester, you can write the big form. Okay. CH3 COO CH2 CH3. I think the Appa had written it from this side. Anyway, you can write it from this side or that side. That's okay. Either like this you can write ester, or you can condense it and write it in this form. CH3 COO, this part, okay, and this part is C2H5. So either ways you can write, both are okay. So ester in the presence of a base, that is sodium hydroxide, what will happen? It will get converted back to alcohol and carboxylic acid. Ulta reaction will take place here now. What you studied there, what happened? Ethanol plus ethanoic acid gave you ester. Now ester, if you add sodium hydroxide, it's going to get reverse. You are going to get ethanol back. So you are going to get CH3 CH2 OH. Okay. And what else you will get? You will get carboxylic acid, which is the carboxylic acid over here, CH3 COOH. Now this H will be replaced by this Na. So we get the sodium salt of carboxylic acid. What do we get? Sodium salt of carboxylic acid. Okay. And this is actually the soap, because soaps are, this is your soap actually. Okay. Soaps are long chains of your carboxylic acid, sodium and potassium also. Sodium, potassium salts of long chain of carboxylic acid. So this is the soap. That is why it is known as saponification reaction. Very simple. Ester you have to take, because soaps have base in it. So we add NaOH. We are going to get back the same reaction back, except that in ethanoic acid, last hydrogen I should replace with sodium. Simple. As simple as that. Fine. Next two reactions you have. Okay. Very simple, very easy. You have already studied this previously, where in your acid, bases and salts chapter you have already studied this. What did we study? Okay, what is ethanoic acid? First let me write that. CH3COOH, ethanoic acid. Ethanoic acid is an acid, right? So it is basically vinegar, which is an acid. Mild acid. Weak acid. That is why we are able to consume it. If to this, if I add a base, what should happen? You tell me. If this is an acid and if I add a base, what should happen? A salt and water should be produced. So a salt will be produced. What is the salt produced? We already saw that. We get long chains of sodium salts of carboxylic acids, right? So you're going to get this only, and water will be released. So this is acid plus base giving you salt plus water, basic neutralization reaction. Apart from this, what do we have? We have the reaction of acetic acid with carbonates. Okay, which carbonates? Sodium carbonate or sodium hydrogen carbonate, Na2CO3. This is also very easy to remember, nothing to worry. See, this is a mild acid. What is sodium carbonate? Sodium carbonates are generally basic in nature. Okay, they are basic in nature. So this is almost like an acid plus base. So acid plus base should give me what? Salt plus water. So I'll write that first. CH3COO Na plus water. Okay, and remember, wherever there is a carbonate group, carbon dioxide will be released. So I can say carbon dioxide is released. As simple as that. Same thing if I do with sodium hydrogen carbonate, it will be NaHCO3. Again, this is acidic, this is basic, same reaction you are going to get. CH3COO Na, water, carbon dioxide. Same, exact same here. Okay, so if you see it from this point of view, it's very easy to remember. Here it is acid plus base, so neutralization reaction. Here also there is an acid plus base, so from here to here it is simple neutralization reaction only. But because the carbonate group is present here and here the hydrogen carbonate group is present, what we will have to do, we will have to make carbon dioxide get released. So carbon dioxide will be released. Okay, what is the name of this compound? You can remember the name of this compound is sodium acetate. So that's it, students. We have reached the end of this particular chapter, and we have also reached the end of this video. That is, we have completed with the revisions of all the chemical reactions that are included in our syllabus. I'm so happy and so proud of all of you who have been with me from the beginning. The courage that you have shown, the determination that you have shown will definitely show in your results. The fruit will definitely show in your results. Thank you so much. It was a privilege teaching you and revising these reactions with you, and I hope that I have done my level best in explaining to you these reactions in a quite simple manner, and all the keywords I have been mentioning, I hope that you have been writing them down, okay, because the notes what you make is very important. I could make up a PPT, upload it on our Telegram channel and make sure you download it. That would all be okay, but unless and until you don't write it, you are not going to remember it. Okay, so write those reactions. Once you have finished these videos, you have your notes ready. Okay, if you're thorough with it, well and good. If not, once again you write all the chemical reactions. Okay, and after that, daily just go through these reactions once. Just go through them. This reaction, this reaction, this reaction, till your boards. Go through them till your boards daily or alternate days. Starting 1 week, go through it daily. After that, you can do it alternate days, okay, till your board exams. So what happens is, by the time your boards have come, you're thorough with all the chemical reactions. And my dear students, chemistry is all about chemical reactions. If you have aced up your chemical reactions, you have almost cleared more than 75% of your syllabus. The remaining 25% is the other parts that you have. That is in the first chapter. I don't think you have much in the other part. What do you have? You just have your rancidity, corrosion part. In the second part, you have to study about the blue litmus, red litmus, those parts. Okay, or I can say at least, if not 75%, at least 50 to 60% of your portion is done over here only. Okay, so the starting part of this chapter, and in the third chapter you have some few topics. Once you are comfortable and once you are thorough with the reactions, you see the confidence you get in chemistry, it will be unmatched. Okay, because the remaining part is just theory and you'll be like, oh, I can easily do it, and you can definitely do it. Chemistry of class 10 is not at all difficult. If you understand it, put your heart into it and study it. Okay, so I wish you all the very best for your board exams. Do ace your exams, and if these reactions have helped you, when you see the paper and if you remember that, oh, mom had told us this and this came up and I was able to do it, please do come and tell me in the comment sections. I would be glad to hear it from you. Very soon I'll be back with some other topic for you. Till then, goodbye, have a nice day. See you in the next video. Also, please do like, share and subscribe to your very own channel Catalyst. Do share this channel with your friends so that along with you, even your friends grow. Thank you. Goodbye. Have a nice day.